Okay, we are going to have an opening prayer from Raymond. I think the person we chose earlier is not ready. So Raymond, unmute and pray.
Oh, it's a pleasure to give me this opportunity to pray for this lesson. Okay, let's also this day. Thank you that this day you have also made it to light up into our lives. It's because maybe that you're still standing here before you. It is you as an bridge of understanding and wisdom to taking that you and everything that's linked up. Amen.
Okay, thank you for the word of prayer. So I think you can proceed to mute so that we can begin our lesson in peace. So, those who attended the very first lesson, I believe you followed it up well and noted where we stopped. So all of you know very well that concerning laboratory preparations of alkenes, I will give you the cheat code or the secret behind all this. So I remember telling you that according to the syllabus book, you are supposed to handle chemical properties or the reaction mechanisms immediately after what we covered the other time got done. So to show you something small here before we proceed. Hope my screen is back. But you people are very bad. No one has warned me that I'm using a workbook of mathematics and not a workbook of chemistry. That is bad. Supposed to use a workbook of chemistry. So this is what I really wanted to show you under alkenes. So those who are with us the other time, just a simple reminder, those sharing the link are for more people to join. Thank you. You're doing a very great job. So we can begin in peace. Introduction, we covered all these things to do with definition, functional group, general formula, and other things. Occurrence and sources, I remember we covered those under research work. Nomenclature and isomerism was as well covered. Concerning the physical properties, you people went with that as assignment. and you were briefed very well. Concerning the laboratory experiments, this was also a tech laboratory assignment. You can do that from your school laboratories at your own convenience. So as you can see, immediately after observing physical properties, the syllabus wants you to handle what we call reactivity and reaction mechanisms. But the problem is, before, that is the old curriculum, there is what they used to call laboratory preparations of these things, which are actually missed, but we shall come across them in the future. So I'm going to talk about laboratory preparations, but then I'll give you a cheat code. I'll be like cheating for you what is going to be done in the other chapters. I don't know if people get that. So we are not going to discuss them, but I'm going to be telling you where we are going to find them, and the book wants you to learn them. As simple as that. But we may not specifically discuss them under this. So we are doing this today, you like it or not. Then concerning this, the test tube reactions, the ones that are used to identify the double bond in alkenes, I told you this one was what? Already recorded. So since it's already recorded, that means that you're supposed to find it from our drive, where most of our work is stored. Then concerning applications, you know, this is always your research work. I'll never teach applications. That is your research. Go to the internet, read books. Everything is available on our drive, of course, for the premium students. So in simple terms, today we are here for only this, but the rest of the things are going to be hinted on, so that even if you're taking them as assignments, you have something to say about them at least. Okay, so to say something about the alkenes, of course, we cannot proceed without lesson targets. I remember telling you that the other holiday, the syllabus book we are using, people claimed that it wasn't student friendly. So those who have been following up the recordings, you know, this is the student friendly one I wrote down myself from scratch, and I'll share it with time. Yes, I'll share it, I think, next week. The week beginning tomorrow on Monday. Midway or at the end. It will be completely ready and I'll share it. So you get it. Print it. Use it to have a sense of direction as far as coverage is concerned. Okay. So the lesson targets, I'll give you a hint. Not teaching, but a hint on laboratory preparations. Someone may ask, but why were these things removed of laboratory preparations? Maybe at your school you were taught. Yes, you were taught, and you're going to realize whatever you were taught is going to be our hint here today. Then these things can be prepared on a large scale in the industries. The alkenes, and alkynes, they can be prepared in the industries on large scale. So laboratory preparation loses meaning, so it may not be so applicable in daily life. That's why it was scooped off. But again, there are some that Isaac and appear in later chapters, something that I'm going to comment on when I begin the hint. Okay, so we shall begin with the hint on laboratory preparations. Begin with that hint on laboratory preparations. Then next, we shall go to the, of course, chemical properties, and we shall write mechanisms where necessary. Then concerning identity of functional group, what is the functional group? The carbon-to-carbon what? Double bond. Those who attended the first lesson, you know this. But I've told you I'm not repeating that because it was already recorded. So for that, I'll simply give you a reference. Yeah, for that I'll simply give you a reference. And then the last thing for this class shall be about the applications. The applications applications of alkenes in daily life. And of course, you all know that this is your research work. I will not do that. The next topic after alkenes is alkynes, but nothing much is going to be done on alkynes. Yeah. If you don't understand alkenes, you will not understand alkynes, because we are going to just duplicate the mechanisms. So for you to actually appreciate whatever is going to happen under alkynes, please understand what we are going to discuss today and whatever we've been discussing since the beginning. That will be the next topic. So that is our simple plan. Those who are not aware, the whole of organic chemistry is going to get ready. Of course, this holiday, we are going to complete the whole of it, apart from what they call polymers and polymerization. So it will be your role to be in position to find out how to revise and how to master your content. But we shall make it clear to you. Simple as that. Okay. So keep sharing the link so that more of your friends log on. Don't let them miss. So we share the link, even those who have just joined, share again the link in the same WhatsApp groups so that people come around. Because we are going to talk about mechanisms, which mechanisms give people the most hard time. Okay. So we start straight away. So I have my simple A heading. Laboratory preparations of alkenes. So under this, what we are going to talk about are the hints. Part A, we can obtain our alkenes from alkynes. Understand? So that means we shall look at that together under alkynes. So that one shouldn't stress us. Under alkynes. That one shouldn't stress us now. It's me who is going to teach them next. So the book wants you to learn reactions of alkynes. But by coincidence, under the reactions of alkynes, in one way or the other, we coincide with how alkenes can be obtained from them. So that's why I call them hints. Again, you come across these things from alkyl halides. You understand? So still, for you to learn how alkenes are obtained from alkyl halides, it will be still under what? It will still be under this topic, under alkyl halides, or what people simply call, they may decide to call them those halogen compounds. Other people may call them hydrocarbons. Yeah, but that's how the book calls them, alkyl halides. Then your alkenes can be obtained from alcohols. And this is a very important method, and I know you will need it. This one, you will not escape it. So in whatever you're doing, at least make sure you know Please make sure you know that how alkenes are obtained from alcohols. Yeah, but as usual, that one will be taught in the topic called alcohols and what? Alcohols and phenols. Yes. So the moment you reach those topics, you will find that as they react at one point or at some points, they form alkenes. And that's how alkenes are prepared indirectly, even when the syllabus doesn't want you to learn them under alkenes, but they will stubbornly come back in later chapters, as I told you. Yes, and basically, those will be enough for you. Yeah, those are enough for you. So you just have this in your notebooks. When that period comes of learning these different things, someone may be like, what do you mean? You people, you look at this. I've told you that the topic that is supposed to come next, we have alkynes. Are you seeing this reaction? Reaction of alkynes with hydrogen. I think here they said addition reactions of alkenes are similar to those of alkynes. That's why I've said if you completely get nothing from this lesson, then you completely get nothing from the lesson of alkynes because they share reactions. As simple as that. So, alkynes, as they react with hydrogen, under certain conditions, they take us back to alkenes. I've talked of alkyl halides. They are the next topic. It will be a term 3 topic according to the syllabus book, though there are schools that are done, which is very okay. So are you seeing? They are talking of halogen compounds in brackets alkyl halides. Then here they are saying chemical properties, or what they call reaction mechanisms or chemical reactions. Are you seeing? As they react with alcoholic alkali, that's when they form alkenes, but you will see that. So realize that the book does not tell you prepare alkenes, but somewhere it tells you to react alkyl halides with alcoholic alkali. These words look scary and unfamiliar right now, but when we introduce the topic and break them down, there will be totally nothing. Yeah, I'm just trying to show you my evidence. So the other topic is under topic 9, where you find alcohols and phenols as the first subtopic. I think it will be senior 6, term 1. Are you seeing? It will be topic 9, organic chemistry 2, those who have been following. So alcohols and phenols, are you seeing this? Chemical properties of alcohols and phenols and their mechanisms. One of the reactions of these alcohols is that these alcohols giving you alkenes. So that's where we shall find that method. So we shall respect the book and just talk about the hints of laboratory preparations and do something else. Just under laboratory preparations, I'll put for you some point of research. I just don't want you to come across weird statements and you be like, oh, Dr. Paul didn't talk about this. My dear, I'm going to. So the other research, I want people to make research about cracking. Yes. Just go and look for the meaning of cracking in organic chemistry. I'm not going to add on a lot of words. That will be some bit of cheating. Yeah. So yeah, you just need 30 minutes. Let me tell you people, if you really prepare enough, you knowing all these terms will be very nice. Knowledge has never been toxic. And they tell us by the time we die, we have used 1% of our brains. So just take in everything as we keep guiding you on what is examinable. But make research about cracking strictly under organic chemistry, not any other branch of science, but strictly under organic chemistry. That's what I want. Okay. So we are now going to go to the next thing. Most of the things have been talked about from alkynes, from everything and everything. Now we are going to go to the, according to this, so I'm done with the hint. So I'll come back and tick. Hints, I'm done. Next thing, chemical properties. I give you the reference, research work, and the lesson is done. So chemical properties, and this is where I need your attention, maximum attention. Chemical properties. I want by the time I'm done with chemical properties, when at least 50 students are still on. People run out of data, people get a lot of issues along the way and they log off. But I pray by the time physical properties are done, we are at least 50 students. So chemical properties, so keep sharing the link so that your friends don't really miss this. These are the properties where students gave most complaints because there are so many, but they have the same format. But students keep on quarreling that they are very hard, yet they are not. Literally, no. I don't buy that. So keep sharing the link, encourage them to log on so that they don't miss. So to take you back, before I actually give you my own, let's first see what the book wants. The book wants you to only talk about reaction with hydrogen, and that's what we are going to begin with. Reaction with hydrogen. Reaction with hydrogen, the reaction with hydrogen, halides, and we shall do that next. Reaction with acidified water, then reaction with halogens. It also wants us to talk about polymerization. Then lastly, oxidation using this. And trust me, we are going to talk about them all. So the first property, the reaction with hydrogen. Before I actually introduce what happens in these mechanisms, I want to first give you a certain hint. First give you a certain cheat code concerning mechanisms so that we don't find hard time when the mechanisms actually start. Cheat code about mechanisms. You people, you all know that and I want you to recall and accept. I want you to recall and accept. Recall that we always have carbon to carbon, isn't it? We always have something like that in these alkenes, if I may say. So I want to talk about two things here. I want to talk about a certain alkene and a certain alkene. We always have two formats of these alkenes. There are those alkenes where this double bond is in the middle somewhere. In the middle, what do I mean? I mean, that there are some other carbon. Let me try to do something better. I've said Have the first case where the functional group or the double bond is somewhere in the middle. Then there are those cases where the double bond is somewhere at the end. Somewhere at the middle, then somewhere at the end, or somewhere in the middle. And I want to illustrate this. When you don't get these mechanisms, are going to disturb you for the rest of your life, because these are the things that actually manage the mechanisms. So this is what I mean. There is when you have something like CH3. I remember we talked about this, something I'm not willing to explain again. This is CH3. Then we always have this carb branch of ours. Please, John the Baptist, leave my screen alone. Remove those blue lines you've put, because I am going to remove you from the meeting, something I really don't want. So that's what I mean, eh? Somewhere in the middle. It may not be exactly in the middle, but somewhere in the middle. Then there are those where the double bond appears at the end of the chain. What do I mean? You're having CH3, you're having CH2, then you're having, this is what I mean, eh? Carbon, this and this. Then you don't need to forget this. So are you seeing the functional group? The carbon to carbon double bond. It's at the end. But then for this case, it is somewhere where? In the middle. Why I'm telling you that the mechanisms shall have a difference is simply because when you look at this one where it's at the end, the two carbons making up the functional group, one is having one hydrogen, just one hydrogen, but the other one is having two of them. Are you seeing that? That when the double bond is coming at the end, and it's not somewhere in the middle, we happen to realize that the two carbons making up the functional group, this is what we call the functional group. Now, people who missed our lessons on the introduction may find issues with this. So I just pray that the majority who are here attended some of our lessons on introduction. So when it appears at the end, the functional group, realize that the two carbons making it up don't have the same number of hydrogens. Never. And I've just said that, I'm not putting it in writing. But when you look at when the functional group is somewhere in the middle, because both these carbons are branching off and continuing the chains from either the left or the right, they happen to have the same number of hydrogens. What do I mean? This carbon is having just one hydrogen, even the other one is just having what? One hydrogen. Do you see that? When it appears in the middle, because it is having chains that are supposed to proceed to the right or the left, leaving it with one bond only to take on the hydrogens. I explained that in lesson 1. That is when it appears somewhere in the middle. But at the end, there shall be a difference in the number. You like it or not, the mechanisms can never be the same. A difference may come about, which we are going to explain. Why am I telling you this cheat code about mechanisms? Those who attended our lessons on the introduction, I don't know who can define for us a functional group very fast. Who can define for us a functional group? Who can define for us a functional group? Anyone who can define for us a functional group? Anyone who can define for us a functional group? Anyone? You people, without that definition, you cannot understand mechanisms. And that's what is giving people hard time. That's why people are not understanding mechanisms. Why? They don't know what a functional group is. you find people doing very weird things. Yes, Emmanuel. Emmanuel, what's not happening? Yes, Emmanuel, unmute and say something. Yes, Emmanuel.
Yes. Good evening, Doctor.
Yes, please. You tell us about a functional group.
So
Please
a
keep
functional
sharing
group,
the link so that your friends log on. Yes,
okay. A functional group is the
Mm.
most reactive point of organic compounds that determines the physical chemical properties of organic compounds or the homologous cells. So, and this can be an atom or group of atoms. Very well.
Exactly, and you've said it all, just like the way you want it. Exactly. So maybe just something little. Those who missed our lessons, I don't know if you can see my screen. Those who missed the lessons of last holiday, like the lessons such as introduction, where we defined all those terms. I remember telling you about our Google Drive. Our Google Drive, you can make research. You are students of new curriculum, you have internet, you find out what a drive is. A drive is something that stores work safely and privately. So this is our Google Drive, as you can see. I'm just showing you how you can literally access this work. Those who missed it and need it. Even those who missed lesson 1. So you can see, you look at only those with stars. The others are very old things. You can see these ones with stars are for August, and we are in August. So we have the Senior 6 chemistry folder that has Senior 6 work. For the new curriculum, you can see Senior 5 work, Senior 5 principal math, Senior 6 principal math. Even the Senior 6 principal math is for the new curriculum. Remember, our goal is to complete the syllabus next holiday. So by this time, we should have covered some of the Senior 6 topics, and they are there already. So on this very drive, when I come here under chemistry, I'll tap where there is chemistry folder. So the topic we are studying now is alkenes, which is a term 2 topic. Remember, I'll share with you the student-friendly syllabus book, which will show you the topics of term 1, topics of term 2. You need these things to plan well. Just like you people cram matches of Premier League and be like, this is when it's going to play. You people cram seasons and episodes of movies and series. You be like, this is when this series is coming out. This is the duration. This is the number of episodes in this season, such things. You can literally do the same for your academics, for your future. Be like senior 5 term 1 topic. Senior 1 form 5 topics are these ones. Senior 5 term 3 chemistry topics are these. So it is a term 2 topic. So under senior 5 term 2 work, when I tap there, you can see we have the organic chemistry 1 part 1. We have the thermochemistry and periodicity 1. These are the only topics of senior 5 term 2. And I'm interested in organic chemistry 1. And organic chemistry 1, you can see 6.1 is introduction to organic chemistry, then alkenes and alkynes. So, and organic chemistry introduction, we have there 2 classes. So are you seeing that lesson 2 that says organic chemistry terminologies? Lesson as far organic chemistry is giving you, some of you had time. You never appreciated what the terms used in mechanisms mean. So you end up not getting anything, because teachers are mentioning things like nucleophile, substitution, addition, elimination, electrophile, which are very weird. So you need these 2 lessons. And you all know, when you pay, you access these live classes we are going to be having, like this one, and also access earlier recorded work. So it is a 2-in-1. So it is only me who has access to this drive, and it is only me who gives access to it. And you all know it is just 25,000 with all senior 5 topics. Because when you look at the alkenes, all lessons are there. Alkenes, we had 3 lessons and we finished them. Then when you come here under alkenes, we had there one lesson. Are you seeing alkenes lesson 1? And what we are doing now is alkenes lesson 2, and we shall also conclude them. So the one who is supposed to give you access to this drive and not anyone else. Don't be convinced. So I don't want to be mentioning unfamiliar terms and you complain. Yet I talked about them earlier. That will be your problem. So let's agree before I actually start. Okay. Even those who need senior 6 work, everything is just there. Those who attended the math lesson of probability, you are aware about that. So back to my screen, back to now business. Let's now discuss the chemistry. So the functional group, according to the introduction and according to the basics of organic chemistry, it can be a group of atoms, it can be an atom, it can be a bond that determines chemical properties. Emmanuel called them principal chemical properties of a homologous series. And all those are terms that we defined, excuse me. So because of all those words, that it is something, group of atom, blah, blah, bond, group of bonds and everything. So my emphasis is on determining chemical properties of an element. Emmanuel added a word and said most active, which is very good. After all, it is most active. That means that being most active simply means that it's what will participate in the reactions. And that's where the determining part comes in. The mere fact it is the functional group that is most active and it's what determines the principal chemical properties, it is what participates in the reaction. So after the word most active, we are going to add on and say it participates in a reaction. Participates in a what? In a reaction. You get the point? I want you to listen carefully. After you understanding that it participates in a reaction, what else do you need? After the reaction, it must disappear. It must disappear. What does it mean? That alkenes have a carbon-to-carbon double bond, which is their functional group, which is their most active, which determines the principal chemical properties, hence it's what participates in a reaction. The mere fact it is participating, we don't expect it to be present when the reaction is done, because it participated. What shows it actually participated? At the end, it is no more. So all reactions we are going to go through, make sure at the end, the double bond is not appearing anywhere. Make sure that the double bond is not appearing anywhere. I've said that and I'm not repeating. We proceed. Proceed. That is one. In these mechanisms, generally, I'm giving you cheat codes of mechanisms. So in mechanisms, arrows, in alkenes we talked about arrows. You understand? Arrows show the flow of electrons. I remember mentioning this when I was teaching. When I was teaching what? When I was teaching alkenes. So that means the reason that's why we use arrows somewhere in mechanisms, it's because of that. Because it's them that show the what? The flow of electrons. But the question is, where are these electrons coming from and where are they supposed to go? You get the point? Where are these electrons coming from And where are they supposed to go? Yes, we have understood that an arrow shows flow of electrons. Flow is okay. But where are these electrons coming from and where are they going? That's the most difficult part. The moment you crack that, then no mechanism will ever give you a time in chemistry. After all, mechanisms are full of arrows. Even when arrows have not been shown, someone has just decided not to, but they are actually there. Let's start. I'll begin with the sources of electrons. Because trust me, when we know the source, the only thing we are remaining with is the destination. So sources of electrons in chemistry. Sources of electrons in chemistry. You people, just cause I've not yet taught you bonding and structure, but it is something that I'm yet to talk about. But if you people have been attending lessons of chemistry right from senior 1, there is something that I expect. Who can tell me, to be very fast, okay? To be very fast, you people know chlorine, and chlorine has an atomic number of 7. You people, I want you to tell me what is the configuration of chlorine. You give me the other one of all level, the one of 2 to 8 to something. Don't give me this one of 1s, 2s, though I taught it, but it's not what I want. I want this one of old level, the old one, 2 to 2 to 8 to 8 to 2, 2 to 1, 2 to 2. If the atomic number is 17, then how will it look like? I want to teach you something very important and sweet. What of homologous series? 2 to 8 to 7. Homologous series, I taught that. So people have said it in the chat, 2 to 8 to 7. Very correct. Yes, 2 to 8 to 7. Now, you people know what they call chlorine gas. This is chlorine, but an atom. You people, I gave you the basics and foundations of chemistry. I told you what an atom is, how it's different from an element, how they are different from a compound, how they are different from a molecule. I taught all those things. So there is what they call chlorine gas. I want you to listen. And you people, this is how chlorine gas looks like. And I believe at least you're not hearing that for the first time. Even in alkenes, we had a reaction they called chlorination. So chlorine gas, because of this two, means that it was formed as a result of 2 chlorine atoms combining. And I recall, you people are aware that if we want 2 chlorine atoms to combine, this is what we do. You understand? Then we'd be like, this is 1 chlorine atom, and then you'd be like, this one is another. Then you'd be like, in the last shell, they have 7. So you come and draw 7 for each. Be like, okay. Let me use X for this one. 7 of them. Those are 6. These are 6. Those are 6. Then you draw the 7th here. Then for this other one, you'll be like, let me use letter E for electrons. You put here letter E, letter E, letter E, letter E, letter E, letter E. You know, there's supposed to be 7. Then the 7th is here. And after you doing that, the thing is balancing. After all, we are supposed to have a maximum of 8. You get? And since chlorine is a non-metal, and both atoms are non-metal atoms, in the previous lesson 1, we agreed that this is what they call a covalent bond. I really don't want you people to miss this lesson. You rather keep sharing the link. And when I release the recording, to please share it. Whatever we are discussing is very important. Because tomorrow I may be forced to introduce alkynes. When you understand this, I just need 1 lesson for alkynes. For around 3 hours and we are done. We do the next thing. However, we have a lot of work in math to do. So you people should be very ready. So what am I actually trying to bring? There are people who now be like, drawing those structures is too difficult, especially when we are dealing with mechanisms. Do you know what we do? We be like, Cl, we put a bond and then say Cl. I told you the rules of bond touching. It's not a must that bonds are supposed to touch, because there is when people make them touch and make them touch poorly. So the best rule is proximity, that these bonds should be very close to the atoms. As simple as that. So we instead decide to show the covalent bond with just a line, because we don't want to draw those Venn diagrams. So what I just want you to learn, people, is very simple. That this thing you're seeing, I think I even discussed this in introduction. It is a bond. But from our Venn diagram, it is clear that that bond is having electrons. That is enough. I'm not interested in the number. But if you want me to put the number is 2. But you can see. But I just want you to see that it has what? Electrons. It has electrons. If you really want me to add on things that will really help you in the future, let me do that for you. If it is a single bond, the electrons are 2. If it is a double bond, the electrons are what? Are 4. If it is a triple bond, the electrons are 6. And later on, I'll teach you the things of bond pairs, because that disturbs people too. But if I may just talk about it for those who are already finding issues, a single bond has 2 electrons, double bond has 4, triple bond has 3. So just a single bond has 2, just from our illustration. But let me shock you. This is one bond pair, this is one bond pair, this is one bond pair. What makes it a pair? Because it is a bond joining 2 atoms. So because it is a bond joining 2 atoms, because of the 2 atoms, we call it a pair. So in simple terms, a bond pair does not look at the number of atoms in a bond. But that is something of bonding and structure, and not now. Even when it has not been gotten, let it slide. Why am I showing you all this? I just want to give you the first source of electrons. I want to give you the first source of electrons as multiple bonds. Because you are not only going to find them in alkenes, but in alkynes too, and other things. What do I mean? Multiple bonds, you can have carbon to what? To carbon. Multiple bonds, you can have carbon to triple bond. Multiple bonds, you can have carbon to nitrogen, triple bond, and etc. In introduction, I talked of multiple bonds. So they are a source of electrons. And I don't want anyone to confuse you about bonds having electrons. We have tried to show the illustration. Okay. Then the other thing I want to talk about is this. I don't know, but chemistry is not a problem. Are you seeing? Those electrons are not paired. They are called unpaired electrons. The other thing I want to add on is that these unpaired electrons, you're not going to cram this chemistry, have not participated in bonding. So I want someone to tell me what name is given to those unpaired electrons that have not participated in bonding. I want that name in the chat. Keep sharing the link and your friends join. What name is given to those electrons which are unpaired? Realize in the covalent bond we have those 2 that have paired. Then these others that are surrounding the chlorine atom, They are unpaired simply because they have not participated in bonding. That's what people are saying. Exactly, lone pairs. That's what I wanted. Lone pairs of electrons. It is even clear that they are appearing in pairs. So the other second source of electrons are what we call lone pairs. Of course, you know why they are pairs. They are these ones. Lone pairs of electrons. And because they have not what? Participated in bonding. So it can also be a source. So some electrons can come from them. But someone may be so enthusiastic. How are they actually written? So when I come and do this, I do this. How many are they? There are 3. So I come here. I write them like that. That is one lone pair. I come here. I do that. They use dots. Some people use those ones like that. Shaded dots or just open dots. All okay, but don't over design. Just use the same format. Then there are people who do this. They put the 2 dots. Then they put something like a cape like that. That one is also, the format is also okay. And those are the formats that are common at your level. Then the last source 3. Source 3, I want to show you something. The other source is a negative charge. Well, I've just decided to write a negative charge because you people are aware that a negative charge means electrons. Aren't you aware? But just to give you a hint and remind you, there is something I talked about in the introduction. That thing was called heterolytic bond cleavage, where these 2 atoms were non-identical, isn't it? And then I said, this one was more electronegative, if you people recall. And then I said this one was more electronegative. Then I said, because it is more electronegative, it will what? It will tend to attract more of the bonding electrons towards itself. That's what I said. Because of that, it will tend to do what? To attract the bonding electrons more towards itself. Then there is something I talked about that as a result, because what it is attracting are electrons and they carry a negative charge, it will have a partial what? Negative charge, and this one will be left with a partial positive. Those who recall, I mentioned that. And as a result, what are you going to have? As a result, we shall come out with a Y with now a final negative charge. But it will only have a final negative charge when Y finally breaks off. You know whether people get it. Remember those things of partial negative, partial positive? They are just when the atom is just tending to, when it is still just a tendency. But when things become real, the Y gets the real negative charge because it has finally attracted the electrons. It has finally stolen them. And when these electrons are finally stolen, then the negative charge can become a source of these electrons. So in mechanisms, those are the major 3 sources of electrons. The moment you have an arrow, make sure that arrow is either coming from a lone pair. If not a lone pair, it's coming from a multiple bond, or it's coming from a negative charge. And don't cram them, because I've not just listed them, I've given you reasons. The moment your arrow is coming from an atom, just an atom, I don't want you to blame me. I've literally hinted on that. Okay. So I think you can see our moderator is in the chat. For those who want to access the recordings of the previous classes, it's called Emmanuel Diba. You can see his number there. So you can inbox him and he assists you with everything. Because I'm going to be very busy handling a lot of topics in mathematics. Because I want people to go back when you're the best people in mechanics. You see, people say mechanics is hard, but it is not. But if at all I give you whatever I'm going to give you and you don't give it time, you remain the same. But if I roar and you act, then you'll be the best student in mechan. So our moderator Emmanuel Diba is going to assist you. Because I'll be very busy, I may be hard to reach. In case I'm hard to reach, you reach out to him. In case you also get so busy, we shall find you another person. So, those are the sources of electrons. Now, the question is, who receives them? Who receives them? You people have it. You think mechanisms people are just designing, putting arrows wherever they want? Never. And when you understand this, the future of mechanisms is going to be very good. Because mechanisms are very many, I assure you. Okay, so when I come here and be like the destination of electrons, the destination of electrons, who needs them? And I want to teach you now. I want to teach you now and listen. You people, we talked of this, X bond Y, that this Y may be more negative. And because it's more electronegative, there may be that tendency of it trying to attract the bonding electrons more towards itself. And because of that, it will attain a partial what? Negative charge. And then this one will have a partial what? Positive. Get the point? Now, guess what? Because of this partial positive, remember here we are just still dealing with the tendency. Something real hasn't happened. It is just a tendency. Just a tendency. Things are just in intense. They just want to intend to happen. So because of this this positive charge, you people, it is a partial positive, but it is still a positive charge. Don't ever be confused. Yes, it is a partial positive charge, but doesn't remove the fact that it is a what? A positive charge. And because of that, this atom needs electrons. This atom, X, needs electrons. Why does it need electrons? These electrons, you are all aware, they have a negative what? Charge. And the X is currently having a positive charge. So you like it or not, it needs what? Electrons. So I don't want you people to be confused. When you see somewhere a double bond coming to attack something of the sort, it is simply because this double bond is a source of electrons, for reasons I've explained. And this X is receiving them simply because it has that partial positive charge, very silent, which brings about that attraction. This one is a source of electrons, and electrons carry a negative charge. So don't you see that there is literally that reaction? So this arrow should be very okay. The flow of electrons now is now coming out because the arrow is coming from a double bond, which is a source of what? Electrons, and it is going to X, which X has a positive charge, which is a partial positive charge coming from some funny tendency we have explained from electronegativity. So that should not confuse you even at any one what? Moment. Hey, that is one of the things. I repeat, that is one of the things that needs electrons. And we are going to use it so much. We are going to use it so much in the mechanisms. And I want you to listen carefully. So this one I'm done and I'm not repeating it. Just get it like that as it is. That is case 1. So the destinations, I'm going to call them cases. So that is destination case 1. I want people to write me in the chat and say, people, I don't want you to tell me case 1 is not okay, unless you have not been following from the word go. But I want to see some 10 people saying case 1 is okay, go to case 2. At least give me vibe to go to the next thing. You tell me to go to the you tell me to go to the case 2. Okay, those are 5. You people are more than 70. Hey, it's okay. Okay, now we can proceed. Now, concerning case 2, I want you to see something like this, and I tell you what will happen next. Let's assume please, Joan, you leave our screen. You remove those blue lines you've put in our screen. Joan, remove the blue lines you've put in our screen. I'm actually going to find a co-host who will be removing such weird people disorganizing us. So assuming we are having ethane, which is of this format. H2, we are having C double bond, then C, we are having that. Now for this case, the 2 carbon atoms are having, each of them is having 2 hydrogens and 2 hydrogens. So here, they may behave in the same way. So let's assume that this one, we can have HCl somewhere like that. And the other things I've been explaining since day one, that this one has a silent positive charge, I've just talked about it. And this one has a partial negative charge, also silent. But when it finally goes off, the charge becomes permanent like that without being partial. It's now a full charge. Yes. Okay. Now what happens? Here, if you really want, and you have a very good handwriting, it is okay to put such things. Remember, we have not started mechanisms. I'm just showing you now the basics. I want you to listen. We are talking of who needs electrons in mechanisms. So, because this is a source of electrons, and let me use green, because this one is a source of electrons and this one is a destination, we agreed this can happen. It is very okay. Make sure the arrow touches the atom it really wants. And then you people are all aware that when that happens, you're now pushing it. You're now pushing this Cl to go off. Let me tell you, that Cl cannot handle that pressure. The pressure from the double bond is too much. The moment they are just there on their own things, the charges are partial. But the moment pressure comes from the double bond and it handles this H, and it attacks that H, the HCSB is like, I can no longer be in this. Let me just leave and ignore all these things. Now, the alkene has attacked the H, meaning that the alkene needs the H. So the H will have to make its way to the alkene. Get the point? It's like being in a relationship where the boy has no money. Yet one of the languages of the girl is money. The moment someone with money comes in, the other boy will have to leave. the relationship without being just, because they will have to fill out of place as a must. So I'm interested in what happens after this. I'm interested in what exactly happens after this. The mere fact that the alkene now needs the hydrogen, and each of the carbons, remember the functional group is made up of 2 carbons. So you're not supposed to be you're not supposed to be, how am I supposed to call that? You're not supposed to favor one carbon. You're supposed to reason using chemistry. Here both carbons have 2 hydrogens. So N can take that hydrogen. But we are going to see what happens. We are going to see what happens when those hydrogens are not the same. You see, we have not yet started mechanisms, but I'm telling you what we are going to meet in the future, and trust me, we are meeting it. So this hydrogen will choose any carbon, and I'm going to do this. I'm going to put for you 2 arrows. So one can choose to go to the first, then we shall have something like this. You people remember, the moment the double bond participates, it disappears. So assuming the hydrogen has chosen the first carbon. Remember, this is how things have been. But remember, the double bond is normal. Maybe, are you seeing this? Maybe this hydrogen has chosen this carbon. I want you to listen. I want you to listen carefully. Something funny is happening. Something funny is happening, and you'll regret if you don't get it. Now this other case, assuming this hydrogen chooses the second carbon. Why is this hydrogen having choices? It's having choices because the battle is between 2 carbons which have the same hydrogen. So they have the same power, the same hierarchy. So the hydrogen can go anywhere. So they are like twins. So this one will remain as H2 carbon. This is now a single bond, but the other hydrogen has decided to choose the last one. Listen, why is it a single bond? One bond is what has attracted this hydrogen. Remember, the bond has electrons, so it has attracted the hydrogen with the positive, and things have just disappeared like that. So after that step, I don't want to see a student bringing back the second bond, because we agreed the moment it participates, it disappears. So what has been a double bond remains a single bond. I'm not repeating that. Now, what is fun is this. I want you people to look at this carbon. Are you seeing this carbon, this one? This carbon is having 2 hydrogens and this one. So the hydrogens are 3, and it is having a 4th bond. And you all know carbon is comfortable or stable with 4 bonds. So this carbon is okay. But when you look at this one, it is having only 2 hydrogens and this 3rd bond. I want you to listen. It is having 2 hydrogens and 1 bond, which is a single bond. Now, what is the problem with this? The problem with this, that this carbon has 3 bonds. If you don't get this, you'll never get it in your entire life. This carbon you're seeing has 3 bonds. We have counted them together. See, people just cram things and put positives wherever you want. But first we are going to explain. Has 3 bonds, hence what? These bonds are less. Let me say less bonds, because they are supposed to be 4. So I will not mention that they are supposed to be 4, but at least you know they are 3, and since they are supposed to be 4, so they are less. So because they are less, the carbon is not used to 3 bonds. So the carbon is not comfortable. Yes, the carbon is not comfortable. Who can tell me the science word that means comfortable in the chat? Someone to tell me which word in science means comfortable. Thank you so much. It's about stability. Comfortability is stability. So the mere fact that this carbon is supposed to have 3 bonds, but the 3 bonds are again less because it must have 4. It's not comfortable, hence it's not stable. And you know, even in real life, we always have symbols. That the symbol of a church, you put a box and a plus. Symbol of a mosque, you draw the moon and then put a star. I don't know if that is it. Then they tell you the symbol for this, you do this. The symbol, you know all those things. Please, the person called the beast, you leave my screen. Remove the green lines you've put. You be organized. Thank you. Remove that green line remaining too. The next person who is going to write in the screen, I'm removing you. I will be sorry. Okay. Now, in chemistry, we attach a positive. We attach a positive. We attach a positive. We attach a positive on the carbon to represent instability or instability. Yes, symbols are supposed to be everywhere. Government cars, you know how government number plates look like. Symbol of a school, you know how it looks like. Symbols of different religions have different symbols. So even in chemistry, the moment instability or instability is noticed somewhere on an atom, we attach a positive on that atom. And the positive is simply there to represent what? Instability. So the moment this happens, we have agreed that this carbon is having less bonds, and that's why I'm going to put a plus here. Are you following? I'm going to come to this one too. This carbon has 4 bonds as we counted the other one, but this one has issues, has only 3, and we shall put a plus on it too. It is better to put the plus on top. But even if you put the plus down, organic chemistry, I told you they are not perfectionists. You'll see that in further lessons. Provided you write something well and it comes out, it will be so okay. You understand? So, after us putting this positive, you people, before I proceed, someone tell me, I know the plus is okay. That one I'm not going to ask. I know the plus is okay, but my question is, so are you seeing all these species? Eh? Are you seeing the whole of this? The whole of this. The whole of that is a species which is having a carbon atom somewhere with a positive charge. You know that people are getting it. That the whole species is having a carbon atom somewhere, and that carbon atom is having a positive charge. And people, that's what they call a carbocation. People, that's what they call a carbo what? A carbocation. I told you people, I think it was chemical formula and chemical equations. I told you what cations are. So just to brief you something small, that a carbocation is a species that is having a carbon cation, that is having a carbon atom which is positively charged. You all know when you see cation, that means positive charge. So when I mention the word carbocation in a mechanism, I don't want you to be confused. When I mention carbocation in a mechanism, I don't want you to be confused. You see, mechanisms are not about a lot of examples, never. It is always one and that is it. The difference comes in when you change the reactant, maybe from ethene to propene, from but1 to but2, but mechanisms do not change. So the word carbocation means carbon atom, cation positively charged. So any species with a carbon atom which has a positive charge, it is given a name in chemistry, carbocation. I've mentioned that and I'm not repeating. Now, I want to teach people how compressing can be done. I want to teach people how compressing can be done. Because you know, in mechanisms, we compress these things. In mechanisms, we compress these things. Now, if you're to compress this, please, the beast, you are back again. You leave my screen, please. Okay. If someone is to compress this, do you know what they will do? They will be like CH2, CH3, then they put a plus here. This is the best thing, because the next thing I want to advise is that it is risky, it is risky to expose, it is risky to expose a single bond that has no use. That has no use in a mechanism. You see, there are single bonds we expose and we need them. You understand? Those who have been following like this, are you seeing this one? That single bond. That single bond was exposed, so it is not risky. Why? We need it. But there are people who go an extra mile and expose certain single bonds that we don't need. So you're bringing risks. Like this very one I've spotted out. The moment you expose it and you don't need it, you're bringing issues. So when I ask you to condense this, or what I've been calling compressing, this one will be CH3, CH2, and then we shall have a plus there. Something like that. So that is a carbocation, even this one is a carbocation. But that is after compressing. That is after compressing. So I want, before I tell you the last thing, I want people to first assure me that carbocations are okay, both about how they are coming about, both about how they are represented, and finally how they are getting compressed, and why we are not showing the single bond and why. If it is okay, then we go to the next thing. Those who are answering their friends in the chat, I like that. Yes, I told you about having a chat secretary in case things are not clear. In the chat, you simply raise the issue if it's really urgent. Okay. Now this is what I wanted to say. This is now I wanted to say. The carbocations we have, the ones I've compressed, we had that. We had this one too. So we are having this carbon atom with the plus. We are having that carbon atom with the what? With the plus. Now, I want to shock people. And then I will say that because of the positive on the carbon, that one becomes a destination of electrons. Remember, we are talking of destination of what? Of electrons. And you people, when I start these mechanisms, I don't want people to give me hard time. I'm going to just teach all of them at once, very fast, and I complete. So you need these things. So you people, I'm saying that when these carbocations have been formed, the carbon has a positive. So by default, a positive can be a destination of electrons because electrons are negative. So that attraction actually exits. What am I trying to bring on board? Let's assume we have these cases. Let me put this carbocation of ours here. And let me put this carbocation of ours here. Now, I want to remind you of something. Are you seeing this reaction where the carbocation was formed? If you people are following very well, are you aware that this Cl, I remember telling you this Cl is that broke boyfriend, that he had to actually leave the relationship in peace because the competitor came in and the competitor was powerful. So the Cl went off completely and permanently, and we agree that when this Cl goes off completely and permanently, it will come out as a full iron with no things of partial arrows. So let me hope people are okay with this Cl with the minus because it was just forced. So by default, it had no option other than going off in peace. And when it goes off, those things of tendency are not there anymore. Yes, the Cl goes off in peace for good and it never returns. Now, remember, you're now having the Cl minus and you're having your carbocation. Now, first things first, I may have my chloride ion there. Then, the other thing, I may have my water. We're going to see different reactions. But then you people are aware that a negative charge is a source of electrons and this one is a destination according to what we've said. So this arrow should not confuse you. You understand? Because the arrow is coming from a negative charge and it's going to a carbon atom that is positive. So the flow is actually coming out. Or the flow is just very fine. I don't expect that to confuse anyone. I don't. Cl is a minus. It is attacking a plus. That attraction is there. Water. You people who know how water looks like. Water has the oxygen atom and it is having two hydrogens. You understand? There is a bond here, there is a bond here. You get the point? And you people know that oxygen, according to the periodic table, is 8. Since it is 8, that means 2 to what? 2 to 6. You all know for this 2 to bond, oxygen brings 1 electron, and also hydrogen does what? Brings 1 electron. There are things you're supposed to just follow, understand, and maybe write notes later. So you realize that for hydrogen it is okay because hydrogen becomes stable with 2. So hydrogen it's already having its 2. But remember, oxygen, out of the 6 electrons outside, it has used only 2. So it has those 4. But remember, these 4 are supposed to be turned into pairs so that the word lone pair comes out. So this oxygen is having a lone pair here and a lone pair here. You get the point? So because of the lone pair there and there, this 6 comes out. Lone pair 1, lone pair 2, a total of 4. 5th electron, 6th electron. The other ones are for hydrogen. And I'm rubbing that off. I've been just doing this to show you that oxygen has lone pairs somewhere. Yes. So those who may not get it, or those who wanted to copy and have rubbed it off, you either get it or you're supposed to be taking screenshots, so that when I warn you that I'm rubbing something, you have the screenshot at least. Or you revisit the recording on our drive, of course, for the premium students. Now, when I'm having my water here like so, we will have water in blue color, water like that. You know that this water, we have agreed that the oxygen atom in the water has a lone pair of electrons, which is like that. Yes. We agreed that lone pairs are also sources of electrons, and we agreed that this one is a destination. So I don't want people to be surprised when you find such arrows in the mechanism. Because a lone pair is a source, and the carbon atom with the plus needs some electrons. There are things I don't want to go into, electrophile, nucleophile, but I think I explained them those days. Electron rich, electron deficient. I'm not repeating those things. You simply revisit the introduction and things become okay. So, you have realized how these things become destinations of electrons and why. And I'm not repeating. Let me tell you, the rest of the things we are going to come across are going to be very easy. That one, trust me. They are going to be very easy. They are going to be very, very easy because it's going to be like revision. But I want to brief people. I want to brief people. I want to brief people. You see why water looks like this? You people, you see why water looks like that? With these things we've talked about, someone may be like, but the water you've used in the mechanism, you have only exposed one lone pair. Because it's what I want to use, yet it is having two of them, but I want to use only one in the mechanism, so I don't want to do other things. So why water is looking like that? Because oxygen is stable, because oxygen is stable with two bonds. Because oxygen is stable with what? Two bonds. People, after this lesson, make sure I give you the timetable for tomorrow and for that coming week starting tomorrow before you actually rest. So one of you should stress me and make sure I release it. It's ready actually. So it's just a matter of converting it into a PDF and I release it and you share it around. So why water looks like that? It's simply because the oxygen atom there is already stable with two bonds. Now I want you to look at case 2. I want you to look at case 2. Which case 2 do I mean? I'm calling this case 1. People are going to get shocked when we begin the mechanisms because everything will have been talked about. You're going and then see this. This is case 2. So I want you to look at case 2. It's what I'm interested in. So let me leave it there. Then I come here and say case 2. Case 2. Now, assuming what you're seeing there happens, that you're having CH3 here, you're having CH2 here, you're having a plus here, you're having the water, yes, it's there. You're having that, you're having this and this. And then you're having that arrow. Now, you people, I'll tell you the tricks, but that arrow should come from between the I told you the sources are very clear. The source are the lone pairs. So the arrow is supposed to come from the middle because the pair is working together. So you're not supposed to allow that atom to touch the O because the O is not the source. The source are lone pairs and the pair is working with the friend. So that means the arrow is supposed to come from between. Yeah, hope that makes sense. So, also draw my water here again. Then we shall make sure our arrow comes from the middle to attack that. So let me put this arrow. Now I want us to see what happens. That is in case 2. Hope you can see what happens. Who put this red line? Stop writing in my screen. I'm really tired of you. I'm really tired of you. Okay, so this is what happens. We are going to have CH3, CH2. And so this O, as you can see the arrow, the O really wants to touch the carbon. Why? The O has what the carbon needs. The carbon is positive. The O has electrons which are negative, so they need each other. And literally that will happen. The O will touch the carbon. You people, we have not yet started reactions. I'm simply giving you cheat codes. The O is there. Then the water, I'll bring the H2. Yes. So you should bring now the H2. It has been on the left. It is very okay to come and place it on the what? On the right. Now, here we are going to be having bad news. Bad news. Which bad news? Let me try to expose this water by putting the hydrogen here. And another hydrogen here, something like that. That's what I'm going to do. And if you people have a very keen eyesight, you realize that the oxygen we have just said above that it is stable with 2 bonds, and that's why water looks like that. The oxygen is now having excess bonds. If you people can see that this oxygen, this one, we have just said it is stable with what? 2 bonds. But now the oxygen is having 3 of them, 2 to the hydrogens and the other one to the carbon. So the oxygen, we are saying it has how many bonds? These bonds are what? Excess. The bonds are excess, so I will say excess bonds. And then excess bonds make it uncomfortable because it is literally comfortable with only, it is comfortable with only 2 bonds. So that means O is not comfortable. But chemistry doesn't change. A is not comfortable. But we have agreed the other science word for comfortability is stability. That means O is not stable. And since the O is not stable, we are going to beautifully come and give O a positive. Shall give O a positive like that. Because it is not stable. So I'll come and say O positive like that. So whether the bonds are less or excess in chemistry, because the less or excess bonds bring about uncomfortability, instability. That atom that is feeling uncomfortable, feeling unstable, is always given a positive as a sign that there is danger here. Simple as that. So this is very important. Very important. Now, I don't want to see an individual putting this positive back. I don't know if people are realizing that this positive has been taken or it has disappeared. Why? This carbon is now happy. This carbon is now happy. That is now having 4 bonds. It's now happy and comfortable. But then as it becomes happy, the oxygen that has given it the 4th bond, the oxygen that has given it happiness, it's now unhappy. And this is the same thing parents do. They are supposed to sacrifice their happiness so that their children are happy. They are supposed to sacrifice a 50k for buying chicken on a Sunday to pay for you Zoom classes at Simos so that you're happy. Same thing has happened here. But now the problem is, after the parent being unhappy for your case, how are they going to get rid of that? Because it's not that they are going to be unhappy for the rest of their life. This must pass and a solution must be found. And I also want to talk about that solution now. Why now? Because I'm still dealing with bonds. I'm still dealing with bonds. So I don't want to let that slide. So when I come, I'm going to show you something of the sort. I'm going to just rewrite this here. So I'll put for you here the word rewrite. I'll put for you the word rewrite. But before I proceed, we have 3 pages so far. I'm going to give people a chance to take screenshots. I don't want us to lose our notes and people complain. So you take that screenshot very fast, so that after the lesson you just copy notes without having the need to review the lessons. And from today onwards, from today henceforth, I need that person who is going to be reminding me about that. Yes, remind me about taking pics so that we don't miss any notes. I think that is done. You can also take that screenshot so that after the class, you can just go through your screenshots and copy the notes. You can also take that of the destination of the electrons. So we are currently there. So we proceed. So I want to rewrite this and tell you what actually happens, because the oxygen must also now be happy. Samsung, you leave my screen. Don't stress me. Yes, I could send the document instead. You will receive it, but we are just taking them for the good of us, because when we lose network, the document is also lost, unfortunately. Okay. Someone is like, what are we learning? That is weird. You people, someone is asking when we are ending. We have just started. We started at around 9. This session is supposed to go up to 11. 2 hours. You know that is the standard time of our classes, 2 hours. Okay. So when I write this, it's going to be like this: CH3, CH2. I'm going to put this one here. We want our oxygen to be happy too, after it has made the carbon happy. So we have H here, So we have a plus here, positive, you get? So we want the oxygen to be happy. What is making the oxygen unhappy is the plus it is having. So these hydrogens are very good people in organic chemistry. Hydrogens are the best. In case we have hanging bonds, they are the ones that come and take up the what? The positions. You all know that. So these hydrogens won't see this oxygen suffering with the instability. One of the hydrogens will be like, we are having this bond. Oh, sorry. Let me put it back. One of the hydrogens will be like, we are having this bond. You all know, all of you are here, you are aware that a bond has electrons inside, and those electrons have a negative charge. And that negative charge can neutralize this positive. You know that people are getting it. This bond has electrons which have a negative charge, and the negative charge can neutralize that positive on the oxygen. So what the hydrogen actually does says, let us sacrifice this bond. How? The electrons in this bond should come and neutralize the positive on that oxygen. That is an arrow that disturbed us from senior 5. For me, I studied these things and later forgot. So when I went to school, we delayed to cover alkenes. I think we covered them towards the end of second term. But these are things I had covered in VAC, so I had forgotten. So this arrow, so I was like learning new things. So this is an arrow that gave us a time from senior 5 term 1 to senior 6 term 1. It was 2019. But later on we had to intervene, and later things became part of us. But we really struggled with that arrow. Most people cram it, but thank God that some of you now know the explanation. The explanation is simple. That hydrogens are very good people in organic chemistry. So they won't allow to see the oxygen unhappy after it has hopped the carbon. So what they would do, they would be like, we are having these two bonds, but each bond is having electrons, which electrons carry negative charge. So they'd be like, can this negative charge neutralize that positive on oxygen? So the positive disappears. Hey, so the oxygen disappears. Sorry, the plus disappears and the oxygen becomes happy. They be like, it is possible. Let's do that. So that arrow means electrons in that bond go and neutralize the oxygen atom because it is having a positive and the electrons are negative, so they neutralize. That's one I'm not repeating. I'm done. So what happens after this? Or what do how do they call this? Yeah? People can take that screenshot. You see, our network is not good. Yeah? So personally, I'm very nervous about it. I don't know what's wrong with all networks. I don't know, maybe they are. The Solid network was okay because I was in the country. But I don't know. I'm really finding it hard and I'm really finding poor network outside the country. But network will become better. Okay, now, where are we? What really happens after this, or how is this called? That's the main point. Now, after all that happening, we shall have CH3, CH2, then OH. Isn't it? Because the H has disappeared and the O has remained with only one H. Isn't it? So we have two things that have disappeared. Our H has disappeared and the plus has disappeared. And disappearing is represented with the minus. I know whether people are getting it. That as this thing is happening, two things are disappearing. The H is disappearing and the plus is also disappearing. That's how we are coming up with something like that. But I want to remind you something. How is this called? How are they really going to call this? This thing has a name. That thing has a name. Before I tell you how that is called, I may tell you how this can be compressed. Yes, this can be compressed. And you decide to write it like this. You can write it as CH3, CH2, OH. and you learn the names with time. You learn the names with time. That's how you can compress it. But I want to tell people about the names. You people, when I reach the mechanisms, things are going to be obvious. And this is the last thing I'm doing. You all know so you people are saying that you all know that H plus is what they call the hydrogen ion. And if we don't call it the hydrogen ion, we call it a proton. You get? And because of this minus, this minus, the one I'm shading in blue, it's like we are losing a proton. You people, why it's called a proton? You all know that protons are positively charged. And if you know the details of a proton, you know that the proton is H plus. So here we are losing the hydrogen ion, or someone can call it loss of a proton, or someone good at English can summarize it as what? Proton loss. So you hear people talking of proton loss, you know what loss is, you know what we are losing, you know how the H was lost, you know how the plus was lost, you know what we have formed. You people, I know you are aware that you know that this is what they call an alcohol. I taught this in the lessons of introduction. I told you that that is an alcohol, and I told you why. You now know the hydrogen ion is what they call a proton. Yes, and you know how everything was lost. So I just want a go ahead from my people who are following in the chat concerning, because you told me the other cases were okay. Did you get that thing? How the oxygen gets unstable and how it loses the stability? You just say we proceed. I will not ask specific questions. Just say proceed, doctor. Because let me tell you, we are done. Let me tell you, we are done. And whatever I'm talking about now is what will be talked about in alkynes. And when I finish alkynes, I'll be remaining with two topics: to complete organic chemistry. Okay. Okay, people are telling me to proceed. Someone is sending me a private message. Someone has said, Doctor, what do you mean you'll be done with organic chemistry, yet there are other topics? Oh, you people, as far as senior 5 chemistry is concerned, so let's just rest a bit as I show you this. Someone has asked a very important question. Someone has asked, Doctor, if you're saying we shall be done, then what of other topics? Does organic chemistry stop on benzene? It doesn't. Remember, you people have as far as senior 5 is concerned, organic chemistry starts in term 2. I think people are seeing my screen. So in term 2, as I said, organic chemistry part 1 has only 4 things: introduction, which we taught; alkenes, which we taught and completed; alkenes, which we are teaching today. Let me tell you this, I'm not going to leave this call until I'm done, because this one is supposed to be 2 hours. Can't you people sit for 2 hours? That means up to 11. So I'm with you and I'm not leaving you. Hey, we are here until further notice. Okay, And then when you go to senior 5 term 3, which is the next term, so I will come here under term 3 work, you're supposed to do only 2 topics, but still under organic chemistry 1, but that will be part 2. So under part 2, you have those 2. You have benzene and methyl benzene, then alkyl halides. So these are the things we are covering. The week starting tomorrow, we shall complete one of these, trust me. So when we finish these 2, I'll be done with organic chemistry. Why? The other organic chemistry that will be remaining is senior 6 work. And when I come here in the senior 6 folder, under term 1 work, you're supposed to do organic chemistry 2. Organic chemistry 2 has 3 things. It has alcohols and phenols, it has carbonyl compounds, it has carboxylic acids. So alcohols and phenols are there. The lesson is there, review lesson. All alcohols, but no phenols. But phenols just need 10 minutes, according to your syllabus. The other part is carbonyl compounds, which were covered 100%. You can see the lessons are there, they are 3. This is a senior 6 folder. Then we have carboxylic acids and their derivatives. They are also there. They were taught lesson 1 and their lesson 2 for their derivatives was also taught. So that's what I meant. The other last part of organic chemistry is in term 3, where you do organic chemistry 3. I think you can see. And organic chemistry 3 has 2 topics. It has amines and polymerization. So amines, I also taught them. I told you there are students who do homeschooling. So there are those students I covered the work with. Because for them, we shall complete the syllabus next month as people report to school. And we shall be remaining with only practicals. Then when you people come back next holiday, then we are also complete the syllabus with you people. So that's what will happen. So organic chemistry, it's only polymerization that we have not covered. As you can see, it is empty. So that will be covered lively next holiday. God willing, of course. So that's what I meant. Hope I answered that person. Right. You people, you are reducing. You're now 57. People's data is done. People have gone for supper. People are tired. But let's push and ensure that we maintain a number of at least, 40. Because we started as almost 80 students. So if half of the number can remain before we close, it's the best thing. 40 students, actually 50. You never know, you may say, oh, the 50. At the end of the lesson, register your names and your emails. I have my moderator on. I give you free classes, all of you. I've said I may. So treat me well. We proceed. Now, I want you to look at this what if before we start the actual chemistry. What if? And it's going to be a question for you people. What if? And in the what if part, I want us to consider propene. Yes. I want us to consider propene in the what if part. Propene, those who attended lesson 1, you are aware that propene looks like this. CH3, this is H, this is double bond, and this is CH2. Isn't it? I believe you are aware. That's how the thing looks like, if I'm not mistaken. Now, I have a concern. Remember, I told you about what they call the functional group. And the functional group is this one. The carbon to carbon what? Double bond. That's the functional group, carbon to carbon what? Double bond. Now, what if you look at it, I remember telling you the difference, that one carbon is having one H, but this one is having 2 hydrogens. For the other one, which had the same number, we say the hydrogen will have no choice. It will go where it wants. After all, the carbons are twins and have the same hydrogen. So my question is, what if this boyfriend with money comes and interferes with this relationship as usual? I've said what if. I've said the moment it interferes with the hydrogen, the Cl will have no option other than giving up. Someone may be like, we need justice for Cl. Why Cl always? Okay, it may be Br. It may be Br, not only Cl. It cannot bear, it goes off like that. We said that if you have a very good handwriting, you can put this. But if you know your handwriting is very poor, you can ignore. So realize you can only make good notes as you're listening, not only screenshots, unless you make the notes there and then. My question is, dear people, where will that hydrogen go? Hey, you people tell me. Hey. The hydrogen has been attacked by the functional group. The functional group is composed of 2 carbons. But now, right now, things are, we have a problem. 1 carbon is having 1 hydrogen. The other carbon is having 2 hydrogens. This hydrogen that they are trying to pull off, where is it really going to sit? The BR has left. It is the poor boyfriend. But now this boyfriend has 2 things. 1 carbon that is better than the other in terms of hydrogen. So 1 carbon is better. That the boyfriend has a kind of motorcycle. What will the girlfriend go for? Will the girlfriend go for a car? Will the girlfriend go for the motorcycle? Hope you're not confused. The car is the carbon with more hydrogen. The motorcycle is the carbon with the 1 hydrogen, so with the less hydrogen. So if it is the girlfriend, the hydrogen they are trying to pull off, where will it really go? I want to see women. You see? Chosen Queen is very clear, the car. She has not even understood. But the moment she had the car and the motorcycle, she said, car. Whether what or what, car. I don't want to know about the chemistry. But if she's even like, never compare a car to stupid things. See? The car. So the hydrogen will go to the carbon with more hydrogens already. Hey, there's a book they call Why the Rich Become Rich and Why the Poor Get Poor. Yeah. So, and in Luganda there is that statement. For me, I used to discuss with the Baganda. So when we always reached this mechanism, someone used to say that ainaya yongerwako. And that thing is even in the Bible. Sorry for the language barrier. But there is that statement that ainaya yongerwako. What does it mean? That someone who is already having will be given more. You understand? So, what is really going to happen? We shall have the CH3, we shall have the C, we shall have the H. This one will now be a single bond. Then the hydrogen will go for this what? For this carbon. This carbon, as you can see, it is having 4 bonds, so it is very okay. These are 2, these are 3, this is the 4th. But when you look at this carbon, I'll give it a plus for reasons you all know. Why? It is having 1 bond, 2 bonds, and the 3rd bond touching this carbon. So it is not okay. It's not comfortable, it's not stable. How do we show it that it is unstable among others? We put a plus on top of it. Then what is the other technique? Is compressing. Yes, compressing now is the next thing. Compressing. Yes, maybe I can just put a statement. So that H goes to the carbon, with the more hydrogens already, with the more hydrogens, already. Hope that has been understood. So compressing is the easiest thing. You just come and be like, I want someone to tell me in the chat. I want to see if really people have been following. Before I even compress this thing of ours, who can tell me something wrong with it? Who can tell me something wrong with it? And I want you to use the right language. Don't just tell me what is wrong with it. Tell me what is wrong with it and the reason you're giving before we can actually compress together. Compressing, we are going to do that together. But I want someone to tell me what is really not okay with that structure. Someone who has been following, I want you to use the right word. When you use the right word, I'm going to give you free classes. Let me watch. Someone is saying formation of the single bond has been exposed for nothing. The single bond being exposed is the mechanism. Expose of the single bond. There is a word I need. I've not. Jolly Grace has tried. There is a word I want. Failed to compress. There is a word I want. I'm waiting for it. When I see it, free classes. But Jolly Grace tried. Jolly Grace, try again. You just type that word that is missing in your explanation. Just the word. Not comfortable. It is risky. Yeah, Jolly Grace. Emmanuel, are you on the chat? Emmanuel, my senior moderator. That's the word I wanted. It is risky. You may do it and they ignore, but it is risky. So, Emmanuel, you get the details of Jolly Grace. Get her email. She's not going to pay. You remind me. And Jolly Grace, if I don't pay, we still have classes tomorrow and Tuesday. If I don't add you to the premium group, you come tomorrow in the chat and say, Dr. lied to me. You go all over WhatsApp and say, Dr. lied to me, promised classes and never. But if they give you money, you talk to me, we eat that money together. Don't ask for money. If you ask for it, you come to me, say, Doctor, they gave me the money, but let us talk. And we shall talk. So, Emmanuel, get her details. That's the word I want. That it is risky, but it may be seen and ignored. But as a student of CMOS, you're not supposed to tolerate such risks. So how things are compressed, we shall just do this. CH3, I put a plus. And trust me, after that, you know what happens. This one becomes a destination of what? Electrons. We are done. You take that screenshot. We now begin the real chemistry. If you fail to understand any mechanism, then the problem is back home. The problem there is now ritual. Because everything has been talked about. Please, people, take that screenshot. So I've said, people, be patient, stay on. You never know by the time the lesson ends. I may say that whoever is on, register, free classes for you. This is what they call, are you seeing that thing I said that goes to the carbon with already more hydrogens? that is called the Markovnikov's. It's called the Markovnikov's rule. Sometimes called, it's because people put in the F, so they find issues with the pronunciation, yeah? But it's supposed to be the Markov, the Markovnikov, the Markovnikov's rule. But those words are not supposed to scare you. For you learn the concept. If you understand women, you cannot fail to understand Markovnikov's rule. Markovnikov's rule. But the first V may be silent. That's the rule that drives that. So very first, according to our syllabus book, this, the things we are supposed to cover. I cannot risk and do the mechanisms in another lesson. That will be a flop. But the remaining 17 minutes we have are enough for us to talk about those things. To talk about all those things. Then you go with some research work as usual. You go with some research work as what? As usual. Okay. Okay. Now, if you first breathe in and out, first breathe in and out. It is now 10:43. It is now going to 44. Just a minute, relax, drink some water. Let me also drink some water, because we are starting now the application of whatever you've been learning. Those who have been writing notes, try to go through your notes. Those who have not been writing, try to think and see whether whatever you've been listening to, you know it. Because now I'm going to be very fast, just writing things. Weirdly, I do one mechanism assignment, one mechanism assignment, one mechanism assignment, one mechanism assignment, or two mechanisms. Two mechanisms. Actually, it's going to be two mechanisms, Markovnikov and without Markovnikov. Assignment for both, like that. Yeah. Hydrogen halides, acidified water, halogens, things. We are done. So just have half a minute. Half a minute. And then the people who are here, let me give you an opportunity. Let me give you an opportunity. When you invite 5 people and they come and study with us, if you will study for free. Yes, only 5 people. You go to your village, you go to your classmates, you bring 5, you write down their names and keep quiet. You tell me, doctor, those are my 5 people. I've wished them well. You get your 5 people, even if they don't have money. Let them at least come and attend free classes. Then they will pay eventually. But even when they don't pay, you just bring your 5 people. The moment you see them among participants, you take a screenshot and tell me, doctor, are you seeing, let me read some names. You'll be like, are you seeing that Flora Sisi? Are you seeing that Anode J1? Are you seeing that Aparango Hope? Are you seeing that Amutu and Aksham? Those are my people. I'm the one who brought them. Give me my free classes. Yes. And I'll do that. I mean, I don't lie. So I think our minute is done. And people have tried to reminisce whatever we've been saying. So let's use our remaining time well. Now you're going to be seeing the same things. Hydrogen. There are lessons we shall have concerning revision, but I want you people to first learn the mechanisms before other things may come in. So with hydrogen, what do we really get? Yes. Now, I want you to note, before I even tell you about the first reagent, that in these things of reactions, we have two things. That for a reaction to actually happen, we need a reagent. Then we need the what? The conditions. You understand? What they call the reagent is what participates. It is a reagent, eh? So it participates actively in the reaction. So I would say, for the reagent, it actively participates in the reaction. Hope you note that. Then, concerning conditions, conditions of course don't participate. Yeah, they don't. Remember biology, photosynthesis, we have raw materials that participate and conditions which must just be present. So these ones do not participate. But someone may be like, what are these conditions always? What are they? What are they? So conditions can be temperatures. So you understand, they can tell you that for this reaction to take place, these are the temperatures required. These conditions, they can be pressures, you get? These conditions, they can be catalysts, you get? And etc. But the reagent, that one actively participates in the mechanism. Conditions, they don't participate, they just have to be present for the reaction to proceed or to actually speed up the reaction, just like a catalyst. So, when I say that A and B like reactions with hydrogen, just like how the syllabus book says. So the hydrogen is what actively participates, and the hydrogen is the what? Is the reagent. You get? A. Hydrogen is the reagent. Now, I remember when I was teaching you still those things of breaking, eh? There is here where we had our XY. I don't want you people to cram chemistry. Are you seeing here that we are having XY and we are only showing how XY is breaking? You people, that doesn't mean that we cannot have X and X breaking. You know that people get what I mean. Eh? That according to our illustrations, we are only showing X and Y. This is what I mean. Eh? We are showing XC, Y, then this one plus, this one is minus. So even when they are similar, X and X, my dear, both are possible. We can have that and that. Still that can happen. So I don't want people to cram chemistry and say, Dr. Paul said for those things to happen, atoms are supposed to be different. No, my dear. Yeah, with chemistry, things are different. That's why we use words. We don't say that those atoms are the same. We either say they are similar or we say they are identical. We can never say X and X are the same, never. We say that X and X are what? Identical, or X and X are similar. Sorry, yeah, similar. but we can never say they are the same. So this thing of them having different electronegativities, or if I may say almost similar, should not confuse you. So if I happen to do it anywhere, don't be confused. So someone may be like, that is the reagent. Do we have any conditions? It's not a must for conditions to come in, but where necessary. But in most cases, conditions are present. You get? So what are those conditions? If you really want an alkene to react with hydrogen, these are the conditions. 1, the condition we may need nickel catalyst or just nickel. And you know the symbol of nickel from the periodic table, it is Ni. If not nickel, if at all nickel is out of stock, someone can use platinum. And you people know how platinum is written. Platinum is what? PT, like that. If at all nickel and platinum are out of stock, someone can use palladium. I don't know if you people know how palladium is written. The symbol of palladium. Who can tell us the symbol of palladium according to the periodic table? Who knows the symbol of palladium? I remember showing you the periodic table in some of our first classes. Palladium is PD. Yeah. By the way, you may even be so blessed. There are people who are good at forging. Someone just says the chemical symbol for the first time and it is correct. Now you listen. You listen. If at all someone decides to use nickel catalyst, you listen. If someone decides, remember these are conditions. So nickel will not participate, platinum will not participate, palladium will not participate. But if you decide to use nickel, remember hydrogen is already there as the reagent, as someone who is going to participate in the reaction. So as the conditions, if at all it is nickel present, you should make sure temperatures of 150 are present, degrees Celsius. Don't forget to put the degrees Celsius, because if you just put degrees as if you mean an angle, yet it is a value of temperature. You get the point? So for nickel, a temperature of 150 should be present. But if you really decide to use platinum or palladium, these two things are used at room temperature. For them, they don't need any more logistics. Yes, here things happen at room temperature. And you all know the value of room temperature is what? Is 25 degrees Celsius. I've not seen yet where the value of room temperature is stated, but they usually just abbreviate it as RTP. I think at least you've realized this. So most people just put RTP. And if you don't put RTP or room temperature or 25, you can ignore that word, ignore the word, and just put palladium, as we are going to see. Can ignore the word. I don't know why, but the subject experts of chemistry have it in the thinking that when someone just puts something and they don't put the temperature anywhere, it's an assumption that the thing is happening at room temperature. That's what is decided. But you can put room temperature, you can put RTP, but you may put 25, and someone who doesn't know a lot of chemistry, they may not get you. And those are issues. Or if you can just ignore the word. You can just ignore the word. So let's see what exactly happens. We agreed I'm going to use the alkene where you may need anti-Markovnikov and where you may need Markovnikov and where you may not need it. And I will apply all these things. So To begin with, the first one, let me use my ethane, this one. Yes, then I say, I'm going to add there hydrogen, and the hydrogen I'm adding there is supposed to be in presence of nickel catalyst, and the temperatures are supposed to be 100 and what? And 50. Those who attended Alkenes, you're not disturbed by these things. I was talking about them. So you people, I don't know whether you're sure that these elements are catalysts here. So I'll put here a note that nickel you're seeing, that platinum you're seeing, that palladium you're seeing, in this context, they are working as what? Catalysts, hence conditions, so we don't expect them to participate. Yeah. So I'm like, when that hydrogen comes, so the question is, what are we really going to form? You recall what doctor said, that since alkenes have a functional group as carbon to carbon, and it is a functional group that participates in the reaction, the moment the reaction is completed, there should be no more. So never allow a reaction of alkenes to have a product with a double bond between carbon atoms. That means the functional group has not done its part, because it's what must react. So if it reacts, the double bond disappears. So how on earth should you have a double bond in a reaction or a double bond in a product where an alkene has been a reactant? I don't know if people are getting it. You're claiming that an alkene has reacted, which alkene has a double carbon-to-carbon bond. And you know that is the functional group which must react since it is most active and it must disappear. So why should it be in the products? Never. That is out. So you're adding hydrogen. You're adding hydrogen. I don't pose the mechanism. I'm going to expose it and immediately rub it off. So if you're very fast, you can capture the screenshot and keep it very far. I'm not going to expose it because I read it in a very complex book that is none of your reference books at advanced level. So mere seeing it may bring issues, but it is somewhere. And this is what happens. And I want to show you that things are now very obvious to do with mechanisms. If you have been following whatever I've been doing, this is what happens. I have my H here. I have this bond. I have my H. That is hydrogen. Remember, we had chlorine, and I said this one is also chlorine after splitting like that. So they have tried to split hydrogen. And guess what I'm going to do? I know this hydrogen has a silent positive, and this one has a silent what? Negative. And I talked about this, isn't it? Why? The double bond is a source of electrons, and this KH is a silent destination. And then this can happen. You get the point? And what do you get after this? You follow. Since the two carbons making up the functional group have the same number of hydrogens, the hydrogen can go anywhere. And I told you compressing. So assuming it takes the first one will be okay, but the second one will remain as it is. And since it will not be okay or comfortable, it will get a plus, isn't it? Then I also told you, now this is already compressed and I don't expect it to disturb anyone because I warned you and I also gave you time to go through these things. So don't give me a time to. Okay, and then the other product is that the moment this hydrogen goes off, serious things now, it has now been broken off, serious things, no more jokes. It is written as H with a minus. I've told you this mechanism is no way, and I'm going to rub it there and then, but I just want you to see the technique. Then those of you who have been following are aware that this negative is a source of what? Electrons. And again, this plus is a destination of electrons. What does that mean? That this KH can come somewhere here, strategic, so that it easily transfers its electrons to that carbon because it is a destination, And guess what will come? The last carbon will finally have also 3 hydrogens. Do you see that? This is how that product has been formed just from the mechanism. And the mechanism has everything we've been talking of. You people are more than 55. I want to see 20 people. I want to see 20 people. We don't write the word catalyst, no need. I want 20 people to tell me that the mechanism is okay, even when it is not at your level. 20 people. Just tell me the mechanism is okay. 20 people. Before I give you the cheat code. Okay. Because I don't want to teach people who are not following. Yeah. Okay. Thank you. Zion Awesome. Zion Awesome is a Munyankole. Isn't it? Zion Awesome. Aren't you Munyankole? Zion Awesome, you tell us. Aren't you Munyankole? I'm waiting for your comment as people send the 20 okays because they are now 13. They are now 15. Zion Awesome has refused to tell us the tribe. Now people are sending the okay more than once so that they can raise the things. I'm not, I'm a Nandi from DRC. Oh, and for us we have a Nyankole, and for us we name weird names. Yes, you can find Ruhanga Awesome. You have seen those people of Mwesige Profit. They are people of Ahimbisiwe Challenge. I started with my Ogi, was called the Asimwe Struggle. I have even students. I have a student called Honest. I have a student called Response. I have a student called Response. I have a student called Response. I have a student called Abundance. And when I find out all of them are of my tribe, all of them are of my tribe. Because I'm also called Lutaya Contradiction. Yes. I also have Prudency. There is Profit. There is forgotten, but the names are always, they are very nice names. So that is done. But I'm going to remove this mechanism as I promised. But I don't know what's wrong with the Baganda. I don't know. Baganda, you should also borrow that. You should also borrow that. But you find a Muganda Matia Mulumba. Then you ask which one is the surname. They say it is Mulumba. Then you ask what is Matia. Then they say it is Matthew. So what was wrong with Matthew? Baganda. They give very good surnames. You find someone called Mulindwa. Very good surname. And then the religious name, Salapio. Mulindwa, very good surname, but Christian name, Salapio. Good surname, Nsubuga. Religious name, Yowana. Yobo. Very good surname, Nanteza. Very weird religious name, Francisca. Fulgencio. That is a bit unfair. Okay. So the shortcut here, someone can just decide to be like, the carbons are going to share the hydrogens and the double bond will disappear. That's what I wanted to say in the first place. Someone is like, is Rutaya a Runyankole name? Yes, I'm a Munyankole, that's my name. But you people spell it wrongly. My name is not like this. This is where you people do the error. This is not L. This is my name. I'm not a Muganda. So that is my name, Dr. Rutaya. Just because Baganda, when they hear Lu, they just want to put everything L. But this is my name, so this is R. So I'm a Munyarwanda. You go to Twitter, you go to X, and put in those credentials. You see all clear information. So, doctor, we don't have to show the mechanism for real. I just have the idea. Just have that idea. Okay, someone is suggesting that we should leave it. Okay, I'm going to leave it. Okay, it's okay, I'm going to leave it. So if you want me really to give you free classes, you come with our names, those weird names. You say, Doctor, I'm Mwesigwa Prophet. Yes. Okay, let me show the mechanism a bit. Though it is not of your level. So I'll put mechanism, then in brackets I'll put ambiguous. Because it is. So I'll come and do this. So do you people see the mechanisms are easy, even when I do them very fast in a sketch form? Why? We have what really happens in the notes area, and that's how other mechanisms are going to be. So I will do this. So I said, if you want, you put those partial charges. So you can first put this. Hope people know how the compressions happen. But now the hydrogen has chosen the first carbon. Now the hydrogens are 3 on that carbon. Then it is not good to expose single bonds, which you're not going to use because it is risky. And then here you just have to put CH2 like that. And because it is unstable, for which reasons the bonds are less, shall put a plus. You shall have here H minus. So now you put here H minus. That will go there. Then finally the alkane comes. This is because one of our friends requested. That's what happens. So if they are to mark first arrow, they put half, then here half. Let me show people what they give marks. This attack is given mark. This breaking off is given a mark. The carbocation is given a mark. The attack is given a mark. Now this one is as a result of this arrow. So they may not remark. And the product is given a full mark, but that mark is put here in the equation that comes before the mechanism, something like that. Yeah. So we have said they give you the same thing. So someone may be like, we are having in like that. But then someone may be there and say, hey, but our teachers write it in like this. I will say this is risky but okay. It is risky but okay. Provided the bonds do not touch the hydrogen. The moment those double bonds touch the hydrogen, it's like now the double bond is between carbon and hydrogen. So you will have spoiled everything. So I've said the other conditions, someone may decide to do what? To say, let me use hydrogen and then palladium. Or the other format can be maintained. And then someone uses hydrogen and platinum. We said someone may say, let me put room temperature or not, of which we have a standard abbreviation RTP, but all of them give you what? This one, of which we handled nomenclature of alkenes, and this is ethane. Ethane, something like that. So I think Wilson had something to say, but he later put the hand down. I don't know why. So I said we are going to be doing 2-2. The one that doesn't need Markovnikov and the other that needs. Yes, Kato, speak. Kato, speak. Maybe you raise up your hand again. I've asked you to unmute. Hydrogen, nickel, temperatures of 150. Yeah. Temperatures of 150 require some heating. So I don't want you to be surprised. You come across a question, come across a textbook, and it is saying heat. I've not said you put heat, even put a star in brackets. But I've said don't be surprised when you find a textbook putting there heat, that this nickel should be hot for it to work as a what? A catalyst. So I said this is easy. This double bond, this one simply does what? Disappears. This carbon gets one hydrogen and this one gets one hydrogen because it is H2, yeah? So double bond disappears and each carbon gets one of them. And what do you get? You get CH3. The carbon that has been CH, it becomes CH2. Then the other carbon that has been CH2, it becomes CH what? CH3. And you know that alkane with the 3 carbons is what they call what? Is what they call propane. That one I remember we did the nomenclature together. So I don't think it is an issue. Yeah. So concerning the mechanism, very fast, you have to recall Markovnikov, because here the 2 carbons that are joined by the double bond don't have the same number of hydrogens. So when the attack happens, the woman, the hydrogen, will go with that carbon that has more hydrogen already. Alina yayongerwako. You all know this will just remain as CH, then this one will become CH3, then we shall put a plus here. You all know this one must finally go off because it cannot handle the pressure and it is now going off serious things, so it will be H minus. So maybe for this mechanism, I didn't have a good handwriting, and it's why I've left this blank on top and also here blank on top. Because I have a poor handwriting, I don't think I can write them well there. That's why I'm doing that. And the moment I see that this is positive, it can receive electrons, and this negative charge is a source. Why can't they do something about each other? So this one will come with its minus, and you all know the flow. And guess what? Propane. Yeah. I'm going to give assignments at once, so that let's hurry assignment, so that I'll even post them in the group. So now let's go to the next thing. I'll give assignments in the end. Now, so the next reaction, part B. So you're now moving. You know, assignments, they take more time. This one is out. Let us now start cancelling. Hydrogen, out. What next? Hydrogen, halides. That is your syllabus book, but the one that is student friendly, written by me. So these ones are hydrogen. Hydrogen halides. So these ones, as usual, they are the what? They are the reagents. Yes, they are the reagents. So we now need to know. Now, you people, I want you to learn this. This word halides comes from halogens. Halides comes from halogens. I remember I told you this in introduction, which halogens are represented like this, X2. What are those halogens? We basically skip fluorine because we don't use it here. So we start from chlorine. We always want bromine, and we always want what? Iodine. So when you talk of this hydrogen, our hydrogen is supposed to have an attack on that, have an attack on that, and have an attack of that, such that we get what they call HCl. Remember, hydrogen and each of them, they have valence 1. Remember, both of them are in group 7. Or hydrogen, we can say it is in group 1. So all of them as a group have valency 1. This one, it is HBr. Those of you who attended chemical formulae with me, I believe this is not a problem. And by the way, if you don't want to find issues with our lessons, make sure when you pay and access the Google Drive, I want you to listen. Make sure when you pay and access the Google Drive, visit all lessons you have never attended, because I will not repeat myself provided something is there on the drive. That one I'm telling you point blank. I'm telling you point blank. I will not repeat something that is there already on the drive. I will just simply be telling you, go to the drive, go to the drive. So you people, the hydrogen halides are these ones. So these ones, this is what we get here, this is what we get here, this is what we get here. So those ones, are what they call hydrogen halides. Hope you've learned where halides come from, what halogens are, and you know they are in group 7. You know what happens when hydrogen reacts with them. You know the thing about what? About the valence 1, why they are looking like HCl, HBr, Hi. But if you attended equations with me and chemical formula, you know all those things. I don't think it is a problem. So now, what is supposed to be? So I would say that generally, they are supposed to appear as what? HX, where Our X excludes chlorine, yeah? Sorry, excludes fluorine. It's either Cl, Br, or that one, I. Like that. Generally, that is it. So someone may be like, you people, as I write the conditions, tell me that the structure of hydrogen halides is okay. You just write a full statement and say their structure is okay. Or you say their structure not okay. At least so that I write the conditions when I'm strong. You people about hydrogen halides. Is their structure okay? You people, you're reducing, you're now 53. You rather share the link. I've told you when the lesson ends, we are about to end. When it ends and the number I talked about is present, I'll give you the free classes. But you people are not listening. This is what people are saying. Structure okay, structure okay. So their structure is okay. That means we can proceed with everything. When you people, the moment we reach 49, even if we just 49 and go back to 60, no more free classes. Okay, so conditions, it's better for the hydrogen halide to be dry. If it is not dry, it should come as a gas, like that. Because in most cases, gases are dry. But there are people that put both, yeah? Why both? Because they say, what if the gas, yes, it is a gas, but it is moist, like water vapor, because it is gaseous water, or vapor just. So something like that, that the hydrogen halide is supposed to be dry, or someone just puts this gaseous state, or there are people who put both. But you know the mechanism is the what? Is the easiest. Okay. Now, as usual, let me first show you the general mechanism. Let me first show you the general mechanism. This is the general mechanism. I'll put here my R, my carbon, my this, like that. Don't mind about anything. So this is what happens. You come, you're having your HX here. You either put these ones, if you have a good handwriting, or you leave them. Should I have a good one? That happens, you know, there is a bond there. Then this one goes off, serious things. Understand? What do we expect? Of course, the hydrogen goes where it's supposed to be, depending. So assuming, okay, let me put these hydrogens. Something I didn't want. Let me not put them. It's just general. Man, yeah, I hate strong chemistry. You know, people may say, but those carbons have 3 bonds. So let me say, assuming that one is stable, because I'm giving a general mechanism, what exactly happens. So by them being stable, I mean these ones have the 4 bonds. The 4 bonds are there. We are doing what? We are assuming, so that the general mechanism comes out, so that no one over comments on our work. You know, there are people who are just there to say, this is wrong, this is not correct, your work is wrong, what? Okay. So you all know, maybe the H comes here, you get, and then we proceed with the CR. Now this one gets a plus as usual, because the carbon because this carbon has taken the hydrogen, and you all know the other X, this one, went off serious things, so it is this side as X minus, but the minus and plus cannot be together. Something must happen, and then you come up with this. Yeah, these general mechanisms disturb, but we are going to handle the real ones. But what I wanted you to see is this. That was the aim of me showing you the general mechanism, and then this thing that is happening here was the aim. Don't mind about the structures. I just wanted you to know that that's how things work. Attack, go off. Hydrogen goes where it's supposed to go. X goes the other side as a minus. It now comes and attacks the plus. Now you people, without considering how the structures are looking like, when we consider, you just considering on the flow, only considering the flow and how everything is written. At least just say that, just tell me that the general mechanism is okay. Don't look at the structure, just the flow. Attack H, X goes off, real things, appears the other side as X minus. Here the carbon that has taken the hydrogen is very okay. The other one that has not taken the hydrogen has a plus. Why? Bonds are less. So what? Uncomfortable. So what? Unstable. So we give it a plus as a symbol. Plus and minus can't be together. Flow of electrons from the source to the destination. Things we have been saying from day one. We are now 50. Chances are high that we are going to hit 49. Yes, finally, people have not been understanding, have decided to just spoil everything. They are like, let us go off, let us not all get free classes. So you pray to God, I don't see the 49. Okay, now, let's go to hands-on now. So assuming I begin with my ethene, some people have been dozing and now their data is off, so they went off. That is ethene. So assuming I have my HCl like that, you people, this is very easy. Before even doing the mechanism, since this one has hydrogens, or since it is in the middle, and the carbons having the functional group have the same number of hydrogens, the double bond must disappear because we are reacting. Get the point? And by the way, here where we had both, I'm going to add on none. Yes, there is when none of them can happen. Someone just puts HCl. Please, you proceed with the mechanism. Don't like this one. They can just put HCl. Just that. Someone can be like, okay, let me put the dry. So here it is easy. This first carbon can take the what? The hydrogen. Then the second carbon can take the Cl. So the Cl can appear at the end like that. I remember in the introduction, I tried to show you such structures. I think we are naming functional groups, so you can revisit. But simply the first carbon has taken H, so it is now CH3. Double bonds must disappear because a reaction is taking place and the functional group is the chief participant. Proof of participation is loss of the double bond. Mechanism is the most obvious thing ever. So when I come to the mechanism, source of electrons, multiple bond, which is in this case the carbon to carbon what? Double bond. I'll come and put here the HCl with the H. Then I put here Cl, H there, that one there like that. So I'll put there my arrow. You know, whatever happens, The hydrogen will choose a carbon it wants. You get? So what if it chooses the first one? So that means this second one is going to be left with a plus. Double bond disappeared because it has participated. If you have a good handwriting, you can do what? Include that. If the handwriting is poor, ignore. Okay. Now, you know Cl comes there like that. C, positive and negative cannot be together. So the negative comes here, yetega, what they call okwetega. It comes there so that it can easily attack the plus. And it successfully does that, as you can see. Yeah, don't overcurve the arrows, but put some vibe and feelings. But the problem with me saying vibes, and now people will do other things. And will be like, okay, doctor said you are supposed to put vibe. This is not what I've said. This is now something different. That's not chemical vibe. Just put two, just put one curve or two, something like that. Very simple and correct. Then I will have my final structure. So I'll come, how are marks awarded? You know that the structure gets a full mark from the equation. First attack, carbocation. I told you that this attack, this one, they can instead award this because that attack gives you the X as a minus. So, okay. Then the other one is this last attack, this last arrow. Something like that. That's what happens. So that Markovnikov, because the carbons participating had same number of hydrogens. What if they are not the same? So I'll come and see part B. The other time I used propene. This time let me use beauty. Butone in here. There I used HCl. Here let me use HBr. And let me not put anything. Now, without even you doing the mechanism, at least you're sure that this hydrogen will go to this carbon Y, it is having more hydrogen, and this Br will go to this one, and the double bond will disappear. Because you know how the chemistry is supposed to be, and you know why everything is like that. So you come and write the product. You people, we are not naming these products because it is not the right time. I assure you we shall find time, and it will be only for nomenclature. You see, nomenclature is good when you talk as I talk as I talk. Right now, let's first struggle with mechanisms. Master them, nomenclature will come later. So here, the carbons are becoming 2, so it is CH2. Even the last one, sorry, it is remaining as CH, but getting a BR, hope people are aware. Then it is the last one that is taking on the hydrogen, and it is becoming CH what? CH3. And all these structures shall be very easy to name. I don't want us to struggle with naming. Why? Because this compound is falling under a topic they call alkyl halides. And under that topic, we are supposed to do nomenclature. So under the nomenclature, we shall be naming this so that you come back now to revise the nomenclature. Right now, just learn how the structure of the product is brought about and how the mechanism is possibly written. And period. But if you believe for you can first write the mechanism before the product, you can be like that until you nab. You can be like that and things really work out. Yes. I think this one must go away. Okay. This hydrogen. This information may be important for people. So when I come try the mechanism, I told you I'll give you the assignment at once. So you're having CH3, CH2, double bond, CH2. You know that this is H. That one. You know all that. So today I have a point writing. I will not put those partial charges on top, yeah? Depends on my mood. Now, hydrogen will go to the carbon with more what? Hydrogens. So we shall have that. Don't forget that that bond will disappear. So here you just have CH, the carbon with its H. Then at the end you will have CH3. I taught you how to compress earlier. So that image of compressing should be in your mind. Then we shall give it a plus. Then the Br went off serious thing. So it no longer has a partial charge, but a complete charge like that. Positive and negative can never be together. Positive and negative can never be together. So when I come here and put Br, but Br with the negative, so literally I can have that R of electron transfer. So I'll do that. Get the point? And we shall get the same product. And you know how literally marks are awarded. So I'll have CH3, CH2, we'll have CH. At the end, I will have CH3. So you are seeing that we are now not struggling because of the information we got earlier. But someone who joined us late is like, hey, these people are taking me so fast. But literally, we had all this information early enough. So I want to see someone telling me that all those mechanisms so far are very okay. I literally want someone to unmute this time round. I don't want you to you are using the chat, you are overusing the chat. I want someone to raise up their hand and speak up. Be like, doctor, all the mechanisms so far are very okay. You go to halogens. Because now here, I'm going to cancel this out concerning hydrogen halides, concerning hydrogen halides. You tell me, doctor, go to halogens because I want someone to raise up their hand and unmute. So I want to go to halogens because I've just talked of hydrogen halides. Then I end with acidified water and the lesson is done. Gloria Gosh. Yes, Gloria Grosh.
Good evening, Doctor.
Yes, please.
The mechanism are very okay. Can proceed.
Can proceed, yeah?
Yes.
Okay, thank you. So, part C, we can now go to halogens. That's what we are handling. Halogens. You all know that halogens, this is their general format, X2. And how do they look like? We said fluorine is not part. So it always that. Cl2. Br2, it can be that sometimes. Okay. And you all know the halogens are the what? Are the reagents. Now we really want to know what are the conditions that come in here. We have condition 1, which is water. You understand? If the condition is water, then we have bromine in presence of what? Of water. And this is what they call bromine water in chemistry. So I don't want that to confuse you again. When you see bromine water, you understand, oh, it is bromine and then that bromine is dissolved in water. Oh, gotten. Oh, it can be chlorine that has been dissolved in what? In water. And this is what they call what? Chlorine water. Or the other condition 2, if water is not the solvent can be carbon, you leave a space, then say tetrachloride. You understand? Now these ones are solvents. So on the other list of hours that was listing the conditions in these things of organic chemistry, you add on solvents. So solvents can also be conditions for reactions. So if it's not called carbon tetrachloride, I remember teaching you myself in Alkenes that carbon tetrachloride, this is how it looks like. Carbon tetrachloride, tetrachloride. Chloride is Cl and tetra is 4. So that's what we have, carbon tetrachloride. I remember telling you the other name of this, and we said the other name is tetrachloromethane. This is one word then. Yeah, things are now different. The other one was 2 words. This one is 1 word, complex. But you learn those things with time. Here, what you're interested in is the structure. Now, what are those 2 reagents we are going to be concentrating on here? So, they will either give you Cl in presence of that carbon tetrachloride, or they will give you the Br in form of the carbon tetrachloride. Now this time round, this is what they call the pure chlorine. It is pure chlorine. Even this one is what they call pure what? Bromine. Why here they are calling it pure? Because yes, both of them are solvents, but this one is inert. By inert, what do I mean? It is inactive. You get? It is inactive in that it will not affect the mechanism in any way, but this water part, for it is active, and the mere fact it is active, it will affect the mechanism. People, I want you to look at that flow chart. It is very weird for this flow chart to come at this time. But the moment you get that flow chart, my dear, the other things are very easy. Trust me, the other things are very easy. All you need to know, what do I mean by active? What do I mean by inactive? Only that. Only that. So let me increase the size of this screen. What I mean by this water being active, I mean that this water, we expect it to participate. in to participate in mechanism. To participate in what? In mechanism. Then here what I mean by this one being inactive or inert, this is actually, it will not participate. So this one doesn't participate. It is enough. It is enough. Water being an active solvent. I want a bold ambassador. I'm going to give you a simple task. I want a bold ambassador who is going to talk about these solvents. Just from that. Oh my God. Oh my God. That's why I always tell you people to endeavor to take the screenshots. But I think I'll have to find a better browser we can use. But that's not an issue. But I'm tired of losing these important documents. Anyway, they really piss me off. I saw that coming. But anyway, I talked of those the halogens and the conditions under which it reacts. That is very bad. And after all, they were the last ones. I remember telling you every time I finish a page, I should have that person who reminds me to take a screenshot so that we have an introduction. But you people just stay quiet. Now I've lost my work.
Sorry.
So we have said we are having that condition for water. Then we are having that condition for CCl4. There are things I will not repeat. Even water, let me just write this. At least you will visit the recording. So someone who needs that flowchart, I advise when I upload the recording, when you open the video, you move the minutes up to when you reach that point you want. Those are videos you can literally skip some part and reach the part you want. So here it was very clear that it can be Br2 with water, then it can be Cl2 with water, and we said this is what they call bromine water. The name, and we said this is what they call chlorine water. Then we added and said that this water is active. What does active mean? That it participates in the mechanism. That's why you even make it part of the name of the overall reagent. Then we said for this one the same thing. It can be bromine in that carbon tetrachloride or tetrachloromethane, or it can be the Cl2, Cl4. And we said this is what they call pure bromine. And I remember telling you why they call it pure. Why they call it pure? It's because this solvent is inert. Inert means it is inactive. So we don't expect it to affect the chlorine and bromine in any way. Yeah. This one is inactive, or what we call inert. So when I point here about participating, I'll put here X, trying to mean for it doesn't what? Participate. That's why they are pure. Because it is just there, it is just there for fun, to just make sure that the bromine is pure, to make sure the chlorine is pure. So it does not participate. But this water which is active, for it does what? It participates. I think this one is even a better table. Okay, now, this is going to be, remember here we have been working on conditions. So this is going to be my condition 1. This is going to be my condition 2. So we begin with condition 1. Condition 1, the format is the same. Condition 1. I will not forget ethene. Ethene is very important. But I've overused ethene. Let me use scope-BUT 2-in. Remember telling you how such a structure is obtained? Are people reduced? You're now at 41. People are tired. People are being stopped to stop studying. But let's keep pushing. Yeah, we should learn, should be consistent. You see why we have lesson targets, and I always fight we accomplish them. I also want you to have that. You learn that it is very good to always stand by your word. So for me, let me do BR. Let me begin with BR2. Condition 1, it was of Cl4. So this one does not participate. Don't even look at it. So that means the product is simple, that the double bond will share the two BRs. You understand? That one carbon, this carbon will get a BR. Even this one will get a what? Remember, it is BR2. That one will get BR. Even this one will get BR. Then the double bond will disappear, because that's what we expect. And when you try to draw the structure, it literally comes out. This one is CH. Then this one is CH. But this one is CH what? 3. What do I mean by it will come out? This one down, BR, and the other one can be on top, BR, something like that. So when you try to count the bonds, all the carbons shall have enough bonds, and they will be okay with whatever is happening. About the naming, we shall name together in the future. So at least you should always endeavor that you understand that you can even write the product before the mechanism. But if for you, your brain is okay with writing the mechanism first before the product, it is very okay also, provided you trust your mechanism. But I've tried to brief you about the mechanism. It is the usual thing we've been doing. It is the usual thing we've been doing. I told you that we shall try to respect the new curriculum, in that I will not be unpacking everything for you, never. I'll be leaving for you some things as research work. You understand? And I want you to bear with me for that. Okay, so I'll come here. BR2, you all know BR2 looks like this. So today I have a very good handwriting. I'll put this and this. So that one will do that. What is going to happen? Now, here, the carbons that are in the competition or joining the double bond have the same number of hydrogens. So the BR will go where it wants. We have always been putting it on the first one. So this time round, let's consider the third one. So this one will remain as CH. Double bond will go off. So this CH is what has received the BR. You get the point? Then this one is going to be CH. And you all know this one went off real things. And when it goes off, it is a real BR minus. You understand? Yes. Don't forget that this first CH that never received the BR is left with a positive charge. For reasons you all know. Get the point? So this BR will come around here. Strategic position, ejja kwetega, so that it can easily attack this carbon. Come up with something like that. And why is our mechanism dirty? You put it in, let me put things in one line. So we are having CH3, CH, we have said it is the second CH that is going to get the BR. Then here we shall have CH3 plus the other BR went off real things with the minus. You understand? Yes. So don't forget that this first one, it was unfair to it. So it was left with the plus. Then the BR came to its rescue, so that stability can finally come through. So you have a negative there. That happens. And finally, our product comes in. So finally, we shall have. So I don't know if people now see why I decided to put this BR on top, yeah? So that it's not affected by this arrow. Because just imagine it was here. It would collide with the arrow. So to solve all that, you put the BR on top so that you have enough space for the coming BR or the coming arrow of the BR. So here you'll have CH. I want to teach a certain technique. Now when you put here the CH, I think that again it may this BR may interact with this one. This is confusion. So what do? So utilize this first CH very well and put its BR on top, because it may not over collide with the other one. Then you shift this BR and put it down. That's what I meant by in organic chemistry. People are not perfectionists. So you just do what you think is working. Eh? Just design your work well, provided you don't over design. Someone again may get biased. So I'll put my BR here down, then my CH3 here. And you know, and you all know how marks are awarded. There is a mark for this. Then to award this, they can decide to award this. There is a mark for the carbocation, mark for the attack. Like that. And this mechanism is the same as that of Cl2. But just because here we've not had Markovnikov. So I think that one is very clear. That one, it is part A. So as I write the question of part B, at least assure me that part A is okay. The good thing we are more than 30. 30 is a very good number. But I really wanted to see if people can keep 50, but people got different issues, which is understandable. I have it, doctor. The person saying I have it, you're going to share it with me after, or you share it in one of the groups. Those people telling me it is okay, let me hope you're being serious. Let me trust you. Okay, now very fast about Markovnikov. You see why I also want to talk about Markovnikov for this? Because people think that Markovnikov is only for hydrogen. But my people, I want to tell you that Markovnikov also works for other things. Like for example, here you're going to see. Actually, let me do for people something very good here. Yeah, so that you also draw the benzene ring today. Make sure you draw it well. It should be the hexagon. The circle should not touch the boundaries, and it should not be so small, yeah? What do I mean? It should not be so small. This is wrong. And it should not touch the boundaries. But I'll teach you this in benzene, yeah? This is also wrong. So it should be there, just okay. But assuming it is having a double bond there, yeah, something like that. What if we want to deal with chlorine and then down we have CCl, or like that? I told you that these carbons just share that Cl. This one gets one Cl, even that one gets one what? One Cl. Let me teach you another technique. This is a ring. When you realize that when you put the things here are going to collide with this B, then you be very wise. This is a ring, so it can rotate. Put things here. You understand? You know the double bond is supposed to disappear. This is CH2, and one is going to get the Cl and another the Cl. Someone may be like, what of this one? We say this one is just inert. It does not participate. It's just there to ensure that this chlorine is pure and it is used fully. It is the water that is active and it participates in one way or the other. And we shall also see that. Yes, we are seeing it actually after this. And trust me, after this, the lesson is done. Yeah, those who are on, thanks for being patient. Very good people. So you know we get a mark for that structure. What people have realized, I've moved the position from here to here. Because this is a ring and can be rotated, and putting the bond here could cause congestion here. That's what I mean by organic chemistry. People here are not perfectionists. Just do what you really, provided you're not against any rule of nomenclature, both structure and name-wise. Just do what you're supposed to do. Now here, I don't want the ring to scare you, because you're supposed to concentrate on your functional group, which is the carbon-to-carbon double bond. So for you, just draw the ring and leave other things. Someone may be like, this hydrogen may affect my first arrow. If that is the case, then put the hydrogen on top like that. Here it has been down, but you put it up. You get it? Just be flexible with these structures, provided the meaning holds. Organic chemistry is the best branch ever. Here we are attacking a Cl. Today I have a very bad handwriting. I'm not going to put the partial charges. I don't even have enough space. So I'll leave them. After that, you know very well that what will I get? I'll have this. Markovnikov, yeah? This carbon, look here. This carbon is having only one H, but this one is having two. So this chlorine is still the woman. It will of course go with the richer carbon, the one with more hydrogens. That means this first one we will keep as CH with the plus. You all know why we have a plus. But then at the end we shall have this Cl with the Cl. You can even put the Cl here as a branch, or you put it normally as we've been putting it. It is very okay. Then you know this one goes off serious things, the Cl. So I'll bring it here, plus the Cl with the minus. Then ejja kujja wano yeetege strategically. Put it there so that it does its attack and we come up with our what? Our product. And you know the mechanism. First attack, awarded. Second attack may be awarded or they may award that. Carbocation awarded. Attacking the carbocation also awarded. The other structure also has a full mark. Get the point? So realize the other things you've been doing from the beginning, they are the same. It's all about who are you attacking, who is going off, how does that go off, how do you compress, how do you do this? Yes, Wilson.
Sir, it's just a reminder about the screenshot.
Hey, you're a very serious person. Yes, you take that screenshot. Then the person with all screenshots should inbox me and get CamScanner app, and you create the document for us and share it around social media. Yes, chosen queen. Yes.
Well, sir, you said about the timetable.
Oh, the timetable, I'm going to share it after the lesson. So after the lesson, make sure before you sleep, chosen queen, I've shared the timetable in all groups.
All right.
Have you heard? Okay. Now, that's all about the pure one. Now, what of the other one with water? Because we need to appreciate all, not only one side. What of the other one with water? Because we need to know. This has been the one of CCl4, the tetrachloromethane or the carbon tetrachloride. So we need to know, what of the other water, where the water is active? How does this water really participate? Why are they calling it active and the others inactive? What are they really basing on? Such things. So I'll come and be like, condition 2. I remember we called it condition 2. Please, I need that person who will be always reminding me. The moment you see that we are done with the page doctor screenshot, we rather lose a page than losing the whole document. And it's all about network. And you know these days it's raining this side. I don't know in Uganda whether you guys are having a rainy season. Let us take the screenshot, please. Okay. Condition 2 concerns water. Now, you see, there are mechanisms we are not yet doing, yet they may ask them. So I'm going to apply them here a bit when I'm doing this of water. But I'm going to do for you only one like this. Only one. Okay. So assuming, so this time round, the one that has no Markovnikov that I'm going to use is this. Something like that. And I'm going to say, what are we adding? We're adding Br2 with water. You understand? A Br2 with water. But I remember teaching people compounds which are cyclic. I even taught you these things of cycloalkenes. I want people to recall that each of the corners there is a carbon atom. So since I'm interested in the double bond, I'm only going to expose that. So that means each carbon is having one hydrogen. So you people, I don't want you to forget this. We are going to use it in the mechanism. You understand? Each of the corners is carbon. So when I expose those carbons, realize each of them has 3 bonds already. So the 4th bond is outside, which is always taken up by the good Samaritan hydrogen. So we can proceed. So you can see you treat it like what? Ethene and those other symmetrical alkenes. Now, let me first do the mechanism before I do other things. Let me first do the mechanism before I do other things. But these mechanisms are two. So alternative 1. But let me teach people what actually happens. Before we even write the mechanism, I want you to listen. Before you even write the mechanism, I want you to learn. The good thing we have a good number here. You listen. Remember, the double bond is supposed to always disappear. You get? So, what I want you to learn is that this Br, sure. Okay, this is how alkenes look like. You are all aware. So, this Br2 takes 1. Then this water takes the other. Someone may be like, why do they concentrate on only those 2 carbons? What of other carbons? You people, we said we are dealing with the reactions where it is the functional group that actively participates. So in whatever we are talking about in a reaction, we are supposed to prioritize the functional group. You get the point? So this is what happens. I want you people to recall when we are doing certain things. Let me see if people recall this. You people, do you remember when I was discussing something, then this water touched somewhere like this, but again after that water touching, this oxygen, we gave it a positive, and then after there we put such arrows, and after there the water remained as OH. Who recalls this? I remember we put water somewhere, it came, but the oxygen got a 3rd bond. So we said bonds are excess. There are those things we did. Who recalls these things at least? You tell me in the chat. Do you recall those things? How people have forgotten already? People, you have forgotten those things we are doing. Oh, if you recall, then well and good. Yes, Arnold, what do you want to say? Okay, now this is it. This is what I mean. You all know the double bond must disappear, so the product should not have the double bond anyway. Yeah, and you know why it's supposed to disappear. So I said the BR, you will take 1 position. Of course, it cannot be there as BR2. That one cannot happen because these things are in group 7, and in group 7 the bond is 1. Why is the bond 1? I taught it in chemical equations and chemical formulae. I'm not repeating that. Then the water takes the other position, but you have all said it in the chat that every time water comes, instability comes in, and water ends up as OH. So in most of the reactions, water contributes OH, like that. So what I'm teaching you now, you are learning how to write the products locally without doing the mechanism. But literally the mechanism may help you to confirm whether your product is right. But you knowing how to come out with the product before you do anything is also wise. So like a case in point, you have this CH3 with this CH3. It is the same as that. And you have here your hydrogens. When you add bromine water, you all know that this bond is supposed to disappear and it remains a single bond. So this carbon needs a fourth bond, even this one needs a fourth bond. So since water is active in the mechanism and the bromine, it's called bromine water, bromine water. So bromine must take, even the water should take. So bromine comes as Br, even water comes as OH. You all know why it cannot come as the whole water, because the oxygen will become unstable and we shall have to lose one H. So this is how you can come out with the structure without doing the mechanism, because sometimes they may tell us the structure, mechanism not required. But when they need the mechanism, well and good. I don't know. I want people to tell me whether how to come up with the structure is okay before we even write the mechanism. Let the bond disappear. One carbon gets Br, the other carbon gets water. But the water comes as OH for reasons you've confirmed in the chart. Br can never touch as Br2. Why? It is in group 7 and it is comfortable with one bond. Just like you see Cl and Cl. This one has used one bond, even this one has used one bond. It is clear that for them, they cannot go beyond a single bond. So the Br cannot touch somewhere as Br2. That is not wise completely. Hope we are on the same page. Sorry, my phone is shutting. So sorry. When you get the recording, skip it until you reach this part and complete the work. Plus, we are still on and enjoying. So, how are you going to write this mechanism? Normally, you're going to come like this. Do that. Put this. Put the Br. Remember, it is, you people, you listen. It is Br2 first. So you begin with Br like that. Because it is bromine first, then water later. So even in the mechanism, begin with Br. So since this is Br2, shall say Br. This is alternative 1. Get the point? Okay. I'll do this. Attack that. Then this one will go off. You're going to also see alternative 2. So this one, partial positive, partial negative. Today I have a good handwriting. Proceed. Oh, these things really look nice. Okay. What are we getting after here? Let me see. The bond has now disappeared, and we agreed the Br is going to take up this position. You people, you listen. You listen. This one is going to be here as Br minus. I want you to listen. You people, when you look at this structure, are you seeing the structure we had here on top? Are you seeing this structure, this one? Do you know how it has become? At this moment, At this moment here. What can I really do? What can I really do? Let me first put it here. It is supposed to be. So here I will say it is like this. H, and H. So whatever has happened, this is the stage at which we are. You follow? We have lost the double bond. Huh? You people, we have lost the double bond. The carbon is there. The carbon is here. We have lost the double bond. The hydrogens are still there. The hydrogens are still there. But this other carbon has gotten a Br. Are you getting the point? At this point is where we are. So this carbon is okay because it is having 4 bonds. If you can count them, let me even shade them in red. It's having that bond with H. It's having this bond with Br. It's having that, and it's having that. So it is okay. But my dear, when you look at this carbon, it is not happy. It is having only and only 3 bonds. And those 3 bonds make it unstable. And you know, when something is unstable, we give it a plus to show the country that this carbon is not happy, it's not comfortable, it's not stable. And in our mechanism, we are supposed, you like it or not, we are supposed to come and put here a positive. That is a positive that can change your entire life. And if you're explaining to a friend, that is a positive you can take months explaining and the colleague doesn't understand. They be like, most people forget it completely. And when you're doing this mechanism, you're not supposed to show all those many hydrogens. You should have those behind the scenes that I'm writing there on top, but write something very neat here down without struggling. So I don't know. I don't know if people are okay with me up to that step. You people, are you okay with that plus? Hope you know that the double bond is always lost. But I'm with that plus. You're not supposed to show the other carbon atoms. You leave the things as corners. These examiners are aware that those corners are carbon atoms. So they know that. You don't need to educate them. But I don't know if my people I'm dealing with right now are okay with that plus. Okay, but I've said they are. Now, now, I want someone to tell me, where we have a plus, OH is supposed to be there. But remember, we have formed the Br minus, and the mechanisms we have been doing, Br has been just coming to attack this and then boom. Get the point? But here we said, even water must participate in the mechanism. So Br has already taken its share. Get the point? Br has already taken its share, so it is out. It cannot come back. Who now comes? Water. You get the point? Now water comes. How are you going to write the water now? It's better you write it like this. OH2. OH2. I told you, just write it in a strategic position. Why am I going for OH2? I want it to be the O to be facing that. Because you know it is the O with lone pairs, and lone pairs are going to be our sources of electrons. You get the point? Now you people know that you're supposed to just expose one that you want. Someone can put it there, someone, you put it anywhere. You get? If not there, someone may say, let me put it here, like this. Whichever you want, Organic chemistry, people are not perfectionists. Organic chemists are not perfectionists. So I'll put everything here and I will do this. You get the point? That I will show the attack. Yeah, I'm failing to do the arrow. Exactly. Are you seeing that? So we realize it is bromine water. Bromine has a share, water has a share. So the moment bromine takes up its share, water now comes in. So don't cram, yeah? Hey, water now comes in. So, and you know what happens after that step? I told you already, so I believe it's going to be a walkover. Because I'm going to come and say, after that, guess what? We shall have our BR. Hope people are okay with that step of water and people know why water is coming. So you shall have BR here. Get the point? This one comes. You know how we are supposed to write our water. It's better we show the H. It's better we expose those hydrogens, eh? Like this. Are you seeing that? Hey. And you all know we are supposed to put a plus here because the O gets extra. And then this plus disappears. Why? The carbon is now happy. So people, remember the other carbon was not happy at first because it had 3 bonds. So this bond of the O is the 4th bond, and you are aware that the water comes, makes the carbon happy, but for it, it is left unhappy. And you know how its happiness is regained. That one of the bonds in this, one of these bonds, either this or this, sacrifices itself. And it's like, let the electrons in our bond, maybe this one, come and neutralize the plus on our oxygen. Something like that. You get the point? And guess what happens after? We lose H, and we also lose a what? A plus. And you all know the final structure. Let me tell you, if you don't practice these mechanisms tomorrow, or those who are still sober, if you can, I highly advise you to practice some of these mechanisms before you sleep. Then you will never forget them. But the brain hates it when you learn things and just sleep. But when you fast, even if you do like, you do a few, don't do so many. So here we know that we are losing a proton. Yes. There are people who tell you that this step can be ignored. Yeah? Don't say that Dr. Post said it is a must, it should appear. So when they tell you it can be ignored, well and good. But may I like what exactly happens? I don't want to leave anything unturned. So this mechanism is very good. There is a mark for this. This intermediate, this BR, attack with water. It has a lot of marks. This intermediate, it is having the proton loss, a lot of good work. And what will make you feel screenshotting this and posting on your status? This is a very good profile picture. I'll even get you a better profile picture. So you also take a screenshot of that as you tell me which step of the mechanism is not okay. If all steps of the mechanism are okay, you just say next. And I won't hesitate, I also proceed. I will not hesitate, I also proceed. So just imagine we have tried to do that is a recyclic. So the other ones that are in chain form are the easiest. Yes, the other ones in chain form are the easiest. They shouldn't stress you at all. Here people have said next. Okay. If people have said next, then who am I not to go to the next thing? So when you're dealing with Cl, it will be the same thing. Eh? Yeah, those things of Br, things are easy. So I told you these things not only work for reactions involving hydrogen, things of Markovnikov, yeah? So I want to show you something. Bromine water, they can put here bromine and then water down, yeah? Or they can combine the whole of it and just call it bromine aqueous, like Br2 with aqueous. But as a student who went through my hands, you should be in position to understand that aqueous means water. So you include water in the mechanism by force. So you all know. So here the mechanism I'm going to do alternative 2. Remember the mechanism has alternative 2. So for this one of Markovnikov, I will do alternative 2 because you need it 2. But for someone who knows these things, you can get the product before the mechanism. How? You know that it is the Br that comes first, and the Br of course will go for this carbon because it has more what? More hydrogen, and water will go for this one. You know this one comes first. So since it comes first, the Br, it will go for what? For this one with more hydrogen. And how will the structure look like? The structure will be like CH3. Structure will be like CH, but we said this carbon takes up the water, which water comes as OH. Then this last one will be CH2. Then the CH2 comes with what? Br. You all know that. And then, that's how the structure looks like. You people, do you get how I'm coming up with the structure before the mechanism? Br comes first. As we attack, it will go with that carbon that is richer. Then water will take the residues, the leftovers, but as the water comes also, it is always left as OH. Okay, I've said we are together. So you get that structure. So alternative 2, what happens? Since it is bromine water, bromine has been dissolved in water. So there could be an alternative of getting the bromine and adding it to water. Let me tell you, as you're writing equations in mechanisms, don't stress yourself with don't stress yourself. I repeat, don't stress yourself with balancing. But I will tell you when you're supposed to balance and not. But these equations we are so far doing are easy in that they balance themselves. So I want to teach you something here small. That as we are writing the equation, we all know that this Br has a certain has two BRs. It has Br and Br. You get? Even this water, we are all aware. Wait, I'll put them in a single box and I warn you. Let me put them here anyhow. So you all know, people, that we have a Br and we also have what? A Br. Then you also know that this water has the H and the OH, isn't it? You all know that Br has one of the Br2 has one Br that is positive, the other Br is what? Is negative. Then the water, you know, its H is positive and its OH is what? Is negative, isn't it? So as those two react, you know, unlike charges, do what? Attract. So those two work together and give us what? HBr plus even these two work together and give you that. You understand? Hey, that's what happens. But I don't want you to put this part of the mechanism. Hey, those are just cheat codes to help you recall so that in the end, everything is part of you. Eh? So these things are not part of mechanism. I don't want you to go back to your schools and say, Dr. Po said this, Dr. Po said this. No, I'm just simply giving you a hint of how you can memorize these structures. Now, it is this one that is looking unique in that some of you are seeing it for the first time. So this one is unique. And because of its uniqueness is what is used in the mechanism. Oh, if the uniqueness thing is not okay with you, maybe you'll forget. You just understand and be like, every time I'm using bromine water, I'm supposed to add bromine and OH. So when you look at this, it has both the OH and it has the Br to be added to the alkene, so it will work for us. You know that people are getting it. If you cannot recall that it is unique, hence we can use it in the mechanism. You can be like, every time we add bromine water, we are supposed to add Br and OH to the alkene, so the other product is better to be used in the mechanism. Not forgetting how it came about. We split the Br2 into two parts and the water into two parts. Then we started attracting unlike charges, positive and negative, positive and negative. Then we came up with those two. But the splitting is not part of the mechanism. So I want people to let me know in the chat whether how the two products came about is okay, and whether the one we are choosing to be used in the mechanism is okay, and you know why we are choosing it. So you tell me, are you okay with how the two products are produced? And are you okay with why we are choosing the last one as unique and as being used in the mechanism? Because that's what we need. Okay, you can proceed. Abudulu Zakiu. Kali. So we are using propene. Now you all know it is bromine that is supposed to come first. So after you understanding that it is bromine that is supposed to come first, we shall write it first. And then if you know that the OH is supposed to come later, shall put a bond, then OH. You know that people are getting it. Remember, it has been like this, the unique thing. Eh? But we know we are supposed to add Br first, then the water later, but water comes as OH. So we rearrange it like this so that we attack Br, OH goes off, and we later add it. Just like we have been doing other things normally. So that's the rearrangement. So as I complete, don't get tired of giving me feedback. So you also let me know if the arrangement is okay. So that arrow goes off. This time round, it's supposed to point the O. Why does it point the O? Because it is the O. It is on top of the O that we put the negative charge. So we should respect that also. Okay. So after that, I'll come and put my arrow there. I will have CH3, listening. Then I will have CH. You all know it will have a plus. Then I will have my CH2 with the BR. You understand? Then the OH went off serious things as a negative. Get the point? Then I told you after that you're supposed to place it strategically for the attack. You know, Kwetega. So that it does that. Get the point? You get the point? Get the point? Here. Then after, you write the final product. CH3, CH, You put here the OH. How these things are named we shall see later. Not now. We shall get sessions of nomenclature. And the BR. So you see, you get your mark for the equation, mark for the attack, this intermediate, this OH, this attack. The product was already marked, they cannot remark it. So you people, those two mechanisms, you get the same product. The difference is that for the first mechanism, you use water as the attack. Then after water attacking, we lose the proton later. But this second one, OH comes as OH. So when we add it, we are done. So I don't know, people, are you okay with both alternatives? Like, are they understood? I don't want you to choose. I don't want you to tell me, I'm choosing this. Who are you? So I don't want people to tell me, Simanya, I'm choosing this, I'm choosing this. You just let me know and say, Doctor, both alternatives are very okay. You just need to understand them. Do I indicate the partials? Depending on your mood. Yes, if you have a good handwriting, exactly. So both are okay. Make sure you practice them and you choose which one works for you. So here I would want someone to do a very good assignment. How? Part A, use alternative 2. Part B, use alternative 1 and see if things will come out normally. You get? Hey. So no one should scare you that organic chemistry is hard. So when we go to our syllabus book, halogens, we are done. And we have realized how water participates. So the last thing I'm doing today is acidified water. Why? Someone may be like, what of others? This polymerization is your research. Remember, polymerization is a topic on its own. You understand? So it may come at the end in senior 6. But you can talk about research because they may be assessing you about alkenes and they make it part. Then this oxidation is the oxidation using potassium manganate 7, which is here, potassium manganate 7, which potassium manganate 7 is already what? Recorded. Applications, I don't teach them at CMOS, but we have our website where we have a library that you can go there and get everything. So literally, we are remaining with only acidified water. We end the lesson. We end alkenes. Next thing will be alkynes. But I think alkynes will be in premium classes. I don't know. It will depend. Because I really want to start on serious things. Things like periodicity, things like solubility equilibria, ionic equilibria, pH. Those nice things. I'm really tired of your organic chemistry. Okay. Now, the easiest and the last one, acidified water. I wanted to end with it that it is the easiest and it is commonly asked. Acidified and someone is not telling me, Dr. Screenshot. Maybe the one who has been saying screenshot is now off. You see, people were complaining, Doctor, your lessons, they go for long hours. You people, I want us to be logical. You be at school for 3 months. You be in the holiday for 3 weeks. Do you expect us to use the same time? You're supposed to go for long classes and cover a lot so that because it is the holiday and it's supposed to be utilized well. So what do you expect? People complain, your lessons go for long hours. What? Very weak reasons. May I will complete my targets. Okay, acidified water is the reagent. So as you know, when they say acidified, you know acids, eh? You people, when they say acidified water, the acid that they are referring to is basically sulfuric acid. And it is concentrated. Concentrated sulfuric acid, which is abbreviated as conc H2SO4, something like that. Conc H2SO4. Yes, we shall be writing it like this, provided you put that dot. It's very important. It's a standard abbreviation, and it's what we are going to be using, and it will have some research work here. Yeah, it will have some research work that I'll leave you with. Okay, now I want you to listen. What is so important about this sulfuric acid? The main importance is that this sulfuric acid produces hydrogen ions. You all know acids from O level, eh? That when they dissolve in solution, they produce hydrogen what? Ions. And you know hydrogen ions are the ones we call what? Are the ones we call protons. And they of that format, H plus. Understand? Produces hydrogen ions, protons, H plus. That's how they look like. Isn't it? So, as we are writing our reagent, it's going to be two-way. But before I tell you that, let me tell you what the condition is. What is the condition for this reaction? Specifically this one with acidified water. It is warming. Yes, I want you to get a difference between warming and heating. Yeah. So because of the acidified water, and we have talked of how they produce protons, we have said it is concentrated sulfuric acid, we have two ways of writing the whole reagent. So here I'm going to just say forms of writing. Forms of writing. I always put things on the arrow. So I'll have that and that. The first option, remember our acid that is used in acidified water is conc sulfuric. So you put 1 and say conc. So here you're supposed to number your steps. Conc, you say sulfuric, like that. Then 2, you show that you need water. Then you warm. You know the people are getting it. Remember we said we are having two parts. We have the acidified part and the water part, you get? So the acidified part, the acid we use is conquat, sulfuric acid, which is abbreviated like that, standard abbreviation. But you need to know what is all about acids. Acids in solution, they always produce what? Hydrogen ions, which we call protons and are written like that. Then I'm like, what is the condition that, oh, yes, we agree you're doing all these, but please and please don't forget to do what? To do some warming. So I'm saying you have two formats of writing. The first format you write that one, I need my conch, sulfuric acid. Two, so this for the word acidified. Then water is this one in step 2. Then warming is the condition and they are marked separately. Oh, if you know that you're not ready to use numbers to show that these things happen in steps, be like acids produce protons. So what we need are protons. So you write protons to represent the acidic part. Water part, put a slash, you write water, don't forget the what? The warm. So here we don't number, but there we number, but same marks. Proton representing acids, publicly, water, just like the name, acidified water. Why proton representing acidified? Because protons come from acids. Warming condition. So, my dear students, is the reagent okay? Are the conditions okay? And the two formats of writing it, are they okay? The condition is just warming, so you never see the word warm in the mechanism. The mechanism is only going to have water and the proton. So are the two reagents, okay, the reagent is one with two forms of writing. So general, are they okay? If someone is asking for the screenshot at this time, you just take what is there. It's not yet full. Are we on the same page? If only one person is commenting, Infinix, what of others? Are we on the same page? Just mere writing it. At least 5 people, okay. Yeah, those are 8. That is good. Even have my namesake, Pauline. Okay. Now, what we form is what will give people hardy time. But I'll put for you a note. Just like bromine water, if it is acid water or acidified water, the acid, which is the proton, takes 1 carbon, then water, takes the other. But you don't need to forget, don't forget that in most cases, or for reasons that you know, water is added as OH. Hope you are aware. That H plus water, just like you recall, Br took 1 carbon as Br only. Water took the other carbon as OH. Which carbons are we talking about? Those carbons that always make up the functional group, yeah? The moment the double bond disappears, or the moment the functional group disappears, Br takes 1, when it disappears, Br takes 1, OH takes 1. So same thing is going to happen here. Hey, H plus and water. H plus will take 1, water will take 1. But don't forget, water always gets added as what? OH. Get the point? These things are best gotten when we do hands-on. For example, let me bring back. Let me bring back our let me do this mechanism with this kind of a thing. We agreed those bonds are not supposed to touch H, but it is okay. But most people render it as risky, but it is not right because it is okay. Now, H plus, water, then I won. What have I said? The one carbon takes the H. Let's say the H is taken by the first carbon, so this one will be CH3. Then the other carbon will take the water, but it takes it as OH, so you form this. I don't know. Trust me, if you people make a lot of practice on these things, time will reach and they are just very easy and no problem. Very easy, and they will have no problem at all. So I want you to be very strong people. You see, for me, I'm just using simple principles. H took 1, became CH3. Water took 1, but it is added as OH. I put it there. Period. Mechanism is something we have been doing. No problem at all. There's nothing like alternative 1 and alternative 2 here. What are people saying in the chat? Hey, we are getting 30. No, it's unfunctional. Good, there's no hydrogen. But doctor, I thought it's supposed to be carbon to carbon double bond. Oh, you people are getting confused. I'm like, you may find your teachers, or you may find it somewhere and it is like that. You see, that thing is not wrong. I told you it is risky not to expose. But what if you come across it? So I don't want you to look at it as something very weird. So it's like I'm exposing you. Because that format is okay, provided those double bonds don't touch the hydrogen. I don't know if people are getting it. I'm the same person who told you, and I'm the same person doing this. I just want you to be diverse as far as content is concerned. Is it okay, Pauline? Okay. But the other one is better. I'm doing this, but it is risky. Hey. But get exposed, yeah? Okay, now I will say, put this here. You people, they will bring facilitators to your schools. And you know facilitators, they are very old men. They don't have that excitement of us, the junior teachers. So for them, they do what has been always done for the past years. But I always tell you that this form is risky. So we shall have an attack of H plus alone without anything. H plus, so this time round, I don't want you to ask for other things. You all know a positive is a destination of electrons and a double bond is a source of electrons. So the arrow is very okay, both where it's coming from and where it's going. I don't expect that to be a problem. So when I put the arrow, I will have, maybe it goes to the first carbon CH3, bond disappears because it has participated. CH2, I'll have a plus here. Now, just like in bromine water, I'll bring my water here. Now here there is no other product, because this one has been H plus alone. So I'll come, put this here. Like that. And guess what? The carbon will now be happy as usual, but the oxygen will not be happy. Why? It will have gotten a third bond, and the third bond renders it unstable, so with a plus. And you all know, to rectify this, we shall have this sacrifice. What does it mean? Electrons in that bond, since they carry negative charge, they come and neutralize that positive. So our product comes. But when you compare this product and this product, we have lost H, we have also lost a plus. And that's what they call a proton. Hence the word proton loss. You people, is that mechanism hard? This mark for this attack, mark for the carbocation, mark for the proton loss, mark for that intermediate. You people, even when we have used the RISC format, but what if UNEB uses it? You don't need to say that UNEB is wrong. So, don't you see that this is the easiest mechanism among all? And thank you for being 30 at 1 a.m. It's really nice, and it's happening for the first time in history for people to be more than 30 at 1 a.m. There is an imaginary line there. Alkenes is generally carbon to carbon. I'm tired of talking about that. So you people, do you see that this car mechanism is very easy? Remember, this one had no Markovnikov because the bond was between two carbons. You get, having the same number of hydrogens. So it is literally no problem. So let me hope people have now appreciated that whatever we began with is what is enabling us for these things to be obvious. Yeah. Okay. Now, I'm going to use weird Markovnikov. The Markovnikov I'm going to use, it is coming at a very weird hour, but I want my people to learn. I want you to be competent students of chemistry. And you people, do you have news about what the Minister of Education and Sports, Janet Museveni, said? Are you aware? Are you aware and are you updated about what she said as far as your curriculum is concerned? Well, I should give you the news. But they are shocking. Are you aware or you're not? Not really. A screenshot. Thank you very much. Let me first teach you, because when I tell you, you may not understand what I want to teach. You take that screenshot. Thanks for the reminder. Okay. Hey, you people, I want us to use this one for Markovnikov. Hey, I want us to use that one. For Markovnikov, and see what is really going to happen. Who can tell me? People, remember we are adding acidified water, and we are concentrating on this carbon in red and this carbon in blue, because they are those carbons that are joining the that are joining the functional group or that are part of the functional group. Where is the water going to sit? Who can tell us? You people, where is the water? Sorry, the OH. Of course, it is water, but water comes as OH. Yeah, Sentongo. But Sentongo, you have been so active. I don't know why I don't know why something is telling me I give you free classes. You have been active for some good time. Where is Sentongo? You unmute and talk. Sentongo Hassan. You have been active. Hmm?
The
I'm not getting you. I don't know. Is it my network? I'm not getting you clearly.
should be put where blue line is.
What have you said?
The OH should be put where the blue line is.
Are you sure?
Yes.
All of you are saying blue. And you people, let me shock you. And you people in the chat, you are the one who are misleading our friend. Someone who put that yellow line, I don't want to stop sharing. You first remove it so that I write my serious things. The person who put the yellow line, remove it. And you be fast. Eh? Remove your line. Okay, let me help you. Okay, there is the other format of the mechanism, but I think you do that as research. I don't want you people to see a lot of new things. The good thing we are still together. And I told you I need someone who has a book where you keep all assignments and research work I leave, so that in the future as we are discussing, that work gets back and we do the needful. So what I'm doing right now, you people, you're not easy. Why am I saying you're not easy? When I do this thing, because most of you are saying blue, why you recall, why all of you are saying blue is because of this. Remember, BR was here and OH was here. So you are cramming, and that doesn't work in chemistry, unfortunately. So we are having a double bond here, we are having CH3 here. So this carbon is already having 4 bonds, but this carbon is the one that is having some hydrogen. You understand? I don't know whether people are seeing that. So do you realize that this carbon in red has no hydrogen at all? But this one has at least 1 hydrogen, which is this. But that one in red, because of the methyl group, it has no hydrogen at all. So so you like it or not, as we are writing the mechanism, hey, are you seeing how Markovnikov becomes hard when things involve these alicyclic compounds, but don't worry, shall handle this. We are in the struggle together. So this is CH3. This is like that. Are you seeing that? We begin attack H plus. H plus is alone. Hey, because of Markovnikov, the paper following. Because of Markovnikov, this one will remain as CH3, and because of Markovnikov, that hydrogen is going to go to this carbon, this one, you like it or not. That's where it will go. And when that happens, like this is what has happened, that this other hydrogen, the proton, has been added here, and the bond has disappeared. Now, when the bond disappeared, just like there, when it disappears, now this carbon is okay, because it is now having 4 of them. You get? It's now having 4 bonds. Sorry, yes, it's having 4 bonds, if you can look at it very well. But again, this one is not okay, so it's the one that gets a plus. So you like it or not, the plus will be here. I don't know. You people, is that okay? Why am I thinking it is not okay? Someone is like, they are not seeing the screen. How true is that? Is it true the screen is not visible or they are possessed? Okay, let me show you again. Let me show you the transition. Transition will be better. Let me even create more space for myself. This has been acidified water like that. This is what I'm meaning. There is a carbon there. There is a carbon here. There is this. There is this methyl. There is this. So this carbon has the hydrogen to make a total of 4. And that is our only focus. We don't need other carbons. Those are the carbons we need because they are the ones that have been participating in everything. You understand? So this carbon in red is very okay. You get the point? And it has no hydrogen. Why doesn't it? Because of the methyl group. The methyl group already substituted it, so it has no hydrogen at all. I don't know whether you're now getting. Now, remember this hydrogen is supposed to go to the carbon with more hydrogen. So this one has no hydrogen, but this one at least has 1 hydrogen. So you like it or not, the hydrogen will have to go to this carbon. You get it? And when it goes to that carbon, remember the double bond disappears. So the CH3 will remain. Even this one will remain with the hydrogen that has been there before. And remember, it's getting another hydrogen. Which hydrogen? This one that they are attacking. This one, they are attacking first in the mechanism. You get? Now, when you look at this carbon in black, it's now having 4 bonds, so it is okay. But now, after losing this bond, our carbon that was in red here is now not okay because it has been left with 3. So the plus will sit there. Are we together? Are we together or I re-explain? People, I think that thing is clear. Do you see that you are going to easily forget it if you don't revise it after? Trust me, there are things you're going to forget afterwards if you don't give them time and practice. Trust me. if you don't give them time and practice, you forget them. Yeah. So do the needful. So you people have told me to proceed. And I'll go on. Now, when you bring your water, do you see where the water is going to go? So I'll put my water here. So as this water is coming, it can even first do that. It can first scare. It can first scare the hexagon. But that is too much. Those are too many curves. Let me see which. Let us not do a lot of designing and cosmetics. Let's just do that. That is the carbon that we are supposed to attack. That's why I prefer my lone pairs to be here so that I draw a very good arrow. But you can put them anywhere. That is my favorite arrow, like that. So are you seeing where the OH sits? Most of you are saying blue, 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 blue. Most of you. And I was disappointed. But it was understandable. It is not something very obvious. So the moment the carbon is happy, again the oxygen turns out to be what? Unhappy. So I want to teach something. I want to teach people something here that you'll be taught. So they will tell you that even if you don't expose the water as we have been doing, so you can literally come, put your O and the H2 without exposing it. After all, we now know the trick. But at least you're sure that the O will have a plus for reasons I explained. You get? Then after that step, you know that here we lose two things, or we simply lose a proton. Put minus and the proton. But you know that we lose the H, we also lose a plus. So you see, you can literally leave it like this, provided you put it there. Those of you who have been following well the marking, have been putting the mark here on proton loss, but have not been giving the mark here for the for what actually happens. But as a student who has gone through my hands, I prefer you knowing what exactly happens. So this attack is a mark. This is intermediate is a mark. This attack is a mark. This intermediate is a mark, and the proton loss. Then you come out with the product. So you see, chemistry is not crammed. Hey, you're supposed to know things. Supposed to know things. And that's how the mechanism looks like. See? One has been worked on. So is the whole mechanism okay? Because now according to the syllabus book, what is supposed to be next is the research work and assignment. So assure me that okay. Now when we go back to our syllabus book, even acidified water, I'll come and put what? A line. So whatever the syllabus book put in brackets, we are done. So let me guide you on how you're going to handle polymerization, where you're going to find oxidation, and the different applications of alkenes in daily life. So as I conclude, Your very first assignment. Are you seeing this? Remember I told you they can be written like this. On top, in case they label steps. That one, then they put water and warm. After all, I taught you how mechanisms run. I taught you the cheat code, and it's going to be the same throughout. So we're going to find out how the mechanism proceeds. Find out how the mechanism. So we're going to find out how the mechanism proceeds. Find out how the mechanism proceeds. That is assignment. This is 1, yeah? Then 2, repeat my own mechanisms first. You understand? I want to teach how mechanisms are practiced. That's why I didn't want to put mechanisms under each. I want to teach you the technique of how mechanisms are revised. So you stay on and learn the technique for good. Repeat how my own mechanisms were written or outlined. You see, before you do an assignment of a mechanism, first try out the very mechanism the teacher wrote or the teacher outlined. You get? After doing that, after you repeating all what the teacher outlined or wrote, you now deal with the assignment. But what is the assignment? The assignment, after trying out what the teacher wrote or outlined, and then change reactants, but maintain reagents stroke conditions. You understand? You change reactants, but you're supposed to maintain. What do I mean by changing reactants? If at all, in my example, I tried this. Now we'll be like, what if it is this? What am I writing? What if it is this? You get? You'd be like, what if it is that very thing, but it is having CH3 here? You understand? You'd be like, what if it is propene? Remember in the first lesson, I told you we introduced the topic and you know how to generate isomers. Understand? And I also taught you for the benzene ring. You'd be like, what if there is a benzene ring somewhere and you are having these two? It is CH2, then here down it is CH3. Like that. Such things, eh? In the first lesson, we introduced alkenes. We saw so many structures of alkenes. So when you try out mine and it is ethene, you go to but 1 in, but 2 in, yeah? X3 in, and others. Eh? So I will just put etc. You try with X3 in. Such things, eh? You just try out others like that. That's how they revise mechanisms. But you first try out those ones I've done. You can even decide to switch. So yeah, I'll say or switch. This switch part, I'm going to just explain it verbally. Someone who just looks at it may not get it. What do I mean? You can get the alkene I used on acidified water. You take it to bromine water. You get that of bromine water, take it to hydrogen. You get that of hydrogen, you take it to chlorine in carbon tetrachloride. You get that of chlorine in carbon tetrachloride, bring it in acidified water. Such things, it's what I mean. Then 3, I want you to make research. I want you to make research about polymerization of alkenes. And make a report. Then 4. I want you to make a write-up on applications of alkenes in daily life. You people, most of you are aware, you were taught alkenes, eh? And alkenes are, they taught you maybe for a week. But you people, let's be sincere. Learning things for a week and then learning them for 2 long nights that are consecutive, which is better? People just want lessons of 2 hours and are too many. For me, I just want 1 lesson and it is here. This is holiday and we are supposed to do a lot of things to conquer the coming term. So don't complain about long hours of classes. You just bear. It's just 2 years. Give in your all, you pass, do other things. Make a write-up on applications of alkenes in daily life. And someone has not asked for screenshot. You people are safe. Then lastly, that is 5. About identity of functional group, 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 and that potassium manganate 7 that I've been talking about. Shall simply refer to senior 5 chemistry folder. Under facilitation. Under facilitation of organic chemistry. You know, the folder is for only the premium students. So briefly back to the syllabus book very fast. We are supposed to start, so even the polymerization I can put a cross, I've talked about it. You need to make research. Oxidation using potassium manganate 7. I've given you the reference. Consider your navy identifying the double bond. Applications, you need the write-up. These ones were all done. So the topic of alkenes is 100% what? Done. I know there is someone who wants to join me and we just disorganize the screen. So, because all that has been talked about and all things have been hit, I will sign out. But before you look at this, let me show you where you're supposed to find that work I've just talked about. So you look at the screen. It is here. Are you seeing these things? Are you seeing where you're seeing the word organic chemistry facilitation? Are you seeing that word? It is the third word, organic chemistry facilitation. When I press there, are you seeing the word that is there? The word says organic chemistry facilitation and identifying functional groups. Let's even try to play it. It was 3 hours and 30 minutes. Let me see where I talked about. Are you seeing it was a organic chemistry facilitation by Tutor Poe sometime back? Let me look for the part I want. I want the part of Alkenes. I really thank God I kept this work. Otherwise, I would be struggling. So this is the part.
We are going to have reagents.
You see?
This is where of course, I'm going to skip alkenes because they don't have a functional group. I will start with alkenes.
See how to identify the functional group in alkenes, and that is the functional group. And you need this work, very correct work with no error.
So we want to know which reagent is going to identify that these are. I say that equation with unless other.
You find time and watch. You see how I wrote the thing? You see the reagent is there, bromine water. Observation, we said it. We had the general equation, if I'm not mistaken. Mark allocation. See? Specific equation, general equation. These are things we have just done.
So you saw ozonolysis. You saw that ozonolysis will break that double bond and it will disappear. Those of you.
So that is the thing I really want you to watch. You will need it very much. So when you check here, your syllabus book, where is your syllabus book? This one. That bromine water you've been seeing, it is here. I rubbed it off. But are you seeing it here? In purple. Bromine water, it's what you've been watching. So literally, to access that drive, it has all the things. I showed you what I mean by the moment I complete the next 3 alkynes, alkyl halides, benzene and methylbenzene, the syllabus will be done as far as organic is concerned. Those of you who have been attending math, you know probability, we are done. And that's how I'll be saying things. Integration, those who are with me, you know, we got it done. Trust me, the syllabus will get done next holiday. Yes. I don't know what you will do for me. So as I listen to these people, Wilson and Bruce, yes, Wilson and Bruce, you unmute and speak.
At the timetable.
The timetable, I'm going to work on it after here because I'll sleep on Tuesday because I slept yesterday. So I'm going to be sober until Tuesday. So I will post it. Don't worry.
It's okay.
So you people, those who have been following recordings, you know our website. You go there and see our library. It is that one. Go there,
It's
create an account. Yes.
Sir, it's my first time. I don't know how to access
The what?
the library and so on.
Oh, are you seeing this? Are you seeing this thing?
Yes.
mmathonline.com. You're going to go and press it in your Google. Then they will bring for your website. You will see our logo. It will be blue in color.
Mm,
You first take a screenshot and have my number. But this number
I'm
of
done,
mine
sir.
is for only WhatsApp calls. Because messages are meant to get too many and I may not be in position to respond to all of them. Because we have a lot of work to cover. So you're going to go to Google. You first take that screenshot. Very first. The website
I'm
and
done.
the number of WhatsApp calls. Yeah, you first
I'm
see
done,
this.
sir.
So you see something like this. Hope you can see the screen. That is our website. So somewhere it has e-library. So the e-library has all books that you need. So you go and access everything. Have you heard?
Okay, sir.
You see? Simosi books e-library, physics, chemistry, biology, and math. You press there, get ebooks. So when you press get ebooks, things are there in details. We have ebooks. Ebooks means electronic books, so they are not hard copies, or what you people primitively call soft copies. So you can see here, biology ebooks, we have biology textbooks. You can see their functional approach. Chemistry ebooks, you can see chemistry textbooks. You have those of organic, physics, and inorganic. Chemistry assignments, we have them there. They are 4 scenario-based. Math ebooks, math textbooks, you can see those of pure and applied. Math assignments, you can see them, they are there. Scenario-based physics textbooks, you can see Roger, Monica, Stanley, Conan, Parker. All of them are there. So you go to the website, create an account, access everything. You get?
Okay, sir.
Then concerning the drive, it is me who is supposed to give you access because it is paid for. Each subject is 25,000, meaning chemistry and math, it is 50K. 50K per holiday. You put the man on that number. Then we study. Is that hard?
Okay. No,
Okay. Yes, Wilson, you speak.
So thank you so much, sir. So like even me, I'm new in the system, so I would like to know how if I want to go in the group and join the group. Even I wanted to talk to you to see how I will take this whole day, how I can access the learning, how I can learn for the holiday. I don't know which plan are you having against me in such.
I'm going to share the timetable because we always have these classes, so we are very serious.
Because like it's
Just
like
know you are in the right place, yes.
then I haven't joined the group because like now the announce I just
Call
got
me
the
now. Have you seen my WhatsApp number? You give me WhatsApp call. Don't send a message. You call me right now on WhatsApp. I add you in all the groups. I also give you the links to share to your other friends in other schools.
Thank you so much.
Okay. Where is this girl? There is a girl I told not to sleep before I share the... She's even off. You see? You see women. Yes, Jonathan.
Yes, thank you, Doctor. Doctor, to my side, I appreciate your commitment, your generosity, and all what you are doing for us. But there is something, Doctor, you forgot to comment about when we were discussing the hydrogenation of alkenes. Uh,
The
there is
anti-Markovnikov.
yeah, the Markovnikov, the
Anti-Markovnikov.
yeah, the hydrohalogenation of alkenes using hydrogen chloride and hydrogen iodide.
I talked about them.
Oh, okay, maybe I did not pick you well. But
We have that mechanism. We did HCl and HBr. What we never tried out was HI, but remember I gave you HI as an example of the hydrogen halide. So I expect someone to do it on their own because I've taught you the trick of dealing with those different mechanisms. You understand?
yes, doctor.
So one thing, actually, let me add it here. Making research about anti-Markovnikov too.
Okay.
But since you know Markovnikov,
Mm.
anti-Markovnikov becomes very easy.
Okay.
Yeah, but you revisit that work very well. I talked about that.
Okay, doctor.
We used HCl and HBr. We never used the HI.
Mm. Doctor, I was talking about the one in the presence of a peroxide where you are using.
That is the anti-Markovnikov.
Yeah, I have got you, doctor.
In presence of such a thing, ROOR, isn't it?
Yes, doctor.
That is anti-Markovnikov. That is your research. It's not part of your syllabus book, but you can make research.
Oh, okay. Okay, doctor.
Because in
Thank you.
the previous book it was clear, but in this book it is not. But it is
Okay.
very easy because it is the exact opposite.
Yes.
But people can make research. Yes, the other one was Markovnikov's rule. Then this one is anti, against it. After all, now we have it under research, so we are safe. So take that screenshot and take the last one. We call it an evening. And thanks for attending. Thanks for the endurance. How can someone call me when I'm still in a meeting? And they have also been part. So you people, any other? I know 10 people are dozing. You see, the other people logged off and they have made you miss the free classes. Okay, I think I can stop share and I can save some books here. Thank you, Doctor, for the lesson. Doctor, thank you for the lesson. May God bless you with $1 million. Those are the prayers I want. Doctor, don't forget our timetable. Don't tell me such nonsense. You be like Pauline. May God bless you with $1 million. The moment you say million shillings, even if you pay 100,000, I will not let you in. So I want 10 students to type the word $1 million in the chat. Then you go. You just put $1 million, amen, $1 million, amen. I want 10 students. Say $1 million, amen, $1 million, amen. You people, you hurry. That is one. As people who are from receiving a free lesson, you are supposed to comply. $1 million, amen, $1 million, amen. Others. Those are 5, those are 7. Those are 8. Even those who are copying and pasting other people's comments, you hurry. Those are 9. Those are 10. You people buy. About what Janet said, we shall talk tomorrow. Okay, Peter, come on WhatsApp.